Palmer.
Go. Atish, I don't know if this is what I'm supposed to be doing. Okay.
Yeah, I can upload the
It
slides.
says on-site room though, so at least that's one good sign. Somebody already logged into this thing. I think this is what I'm supposed to be doing. Atish, this is what I'm supposed to be doing.
Can you hear me?
Hopefully this is right. I don't know. Whatever. Yeah. But at least this, you can see us. Yeah. Okay. Well, whatever. We'll see what happens. Can't be that bad. Okay, Atish, I think we can't hear you locally. I think we're supposed to not be able to hear you locally. Everyone else is just typing. Now I'm worried there's... Oh, were you... Sorry, I didn't see you back there. I have no idea how this works. I managed to miss both of the orientations. Okay. And then I just saw. Cool. And that goes out to the computer string. Okay, cool. All right. Yeah, thanks. Sorry. Super out of it. Okay, so hopefully that's good enough. Hey, Rylan, do you want to go get the mic from the guy so you can get set up? Get the mic on there. Yeah, they're in the back because you're going to talk for a little while longer. Just get the mic attached to yourself for your talk.
Was there a video of a video? Did they do video for your competitor presentation? I don't know. Okay. Like also like very okay. That the whole thing was pretty strange. Like it's all big. Yeah,
Give that as you wish.
Okay, cool. Thank you very much. Great. Yeah, thanks. I managed to miss both of the orientations if there were.
Well, you still get to, I can help you out with PC, but you get to do it. So I'm going to sit over there. and
Yeah, that's
explain
totally
it.
fine. I just wanted to make sure that I was supposed to just attach this PC to DVB, just join the thing, and that's
it.
okay. All right. I was worried that I was doing something wrong, but when it was logged in, I thought it was okay.
Yeah. Anyone else coming here?
That I don't know.
Can you hear me, Atish?
They are, so
Sunil here.
you can clearly see that we're transmitting from here.
Yes, but are there our mics that's work for us.
Yes.
Okay.
Is he trying to speak and come? Do it fast.
Yeah. Did it? Okay. Well, hopefully, muting this will fix it. We still have a couple minutes before we start. With the online ones, it's better to just kind of stick to the schedule. That's what we usually do. All over the place. Not hard to tell, too, sorry.
So do you hear me? The room?
You hear me now?
Yes, we can hear you, Atish.
There's a lot of echo, I think, in the room. Just wanted to see if video works. I guess it works. Yeah, I can see it.
No, insisted on the rules.
Yeah.
If you break them, then right?
Hey, Pamar?
Yeah.
Yeah, I uploaded all the slides and there's an intro slide, so you can start the intro when it's time.
Yeah, I think we're supposed to start with the sponsors. And
Yep.
then
You can switch to the intro slide.
That's, yeah, okay, I was trying to figure that out earlier.
You won't see the only screen we got on this one, unfortunately. So we
Okay,
won't see
yeah.
the video of any attendees, so you might want to go full screen again if somebody unmutes the video to ask questions.
Okay, yeah, I'm not sure what the right answer is there then.
Well,
Start with
it's a
this
lot of
for now.
manual work by you, fortunately.
Yeah. It's just when things move around on video streams, it'd be kind of hard for folks to follow, but we'll start this way and see what happens. It works. I think we do have a lot of people attending remotely. 15, so. Yeah. Not too bad. Are you going to the Q&A thing? I didn't register for whatever it's at DLC or. Yeah. Yeah, the timing's like the worst, so I don't know what else to do.
Hey, Alistair.
Oh, hey, dude. Can you see us?
Yeah,
Nope.
yeah, you could see him.
I can
Like,
see
click the
only
button.
Palmer.
Yeah, Mike did.
Oh, I thought there was a second camera.
I'm stuck here.
Yeah. Yeah, Tish.
Hi, Damien.
Another camera over in this corner.
Hey, Alistair.
Oh, there's Dish.
Yeah, there's a lag.
Yeah,
Hey, Pamal.
yeah. Okay.
Hey, Damien. How are you?
No, there's a whole list over on this side here. Yeah. So, all the folks. Yeah. Oh yeah, I guess that makes sense.
Was Sunil remote?
Yeah, we have a couple of remote presentations. Okay, so it's 3, so we'll get going with the introductions. These generally only take till 5 minutes anyway, though. So I can start out by thanking our sponsors who are on the slides, as you can see. So always really great. It's really important to make sure that the in-person events are happening again. Very good for collaboration and whatnot, and they wouldn't happen without the sponsors. So important to make sure everybody's on there. And we'll just do a brief introduction slide with the schedule and whatnot. So yep, here we are. So we have a full schedule in the micro conference today. A handful of folks are leading discussions. If you haven't been to Plumbers before, I think most folks probably have. They're very discussion-oriented conferences. So we have somebody leading the discussion, but generally good to ask questions and whatnot. Point of doing a thing in person is to make sure that folks can talk to each other, that sort of thing. With the half remote conference, it'll obviously be a little bit different, but we just have to make sure that we're checking the chat and whatnot so that everybody can kind of participate. That's about it from my end.
How many are there in the room? I see 17 in remote. Maybe some of them are logged in.
Yeah, I think maybe more like 10 remote, actually remote and actually people. The on-site room is in here a bunch of times. But yeah, so I think generally with the remote conferences, we like to just stick to the schedule. It's a little easier that way for people coming in and out and whatnot. If you have questions, obviously happy to talk now. Otherwise, we'll wait for a couple of minutes and then Runelin can start giving his talk.
There is one guideline that when remote attendees asking any questions or saying anything, if you can unmute your camera, that would be helpful. If you can, otherwise it's fine.
Yes, because if you haven't used BBB before, it can be kind of tough to tell when someone's talking unless their camera pops up. So, if you want to talk, pop your camera up and then pop it back down again. Just makes it a little easier to tell someone's there.
Is anybody in the room taking notes?
So you're welcome to come for Linda. I think we're good to go for now. And yeah, just wait a minute or two. Just again, stream viewers and whatnot, it can be kind of hard.
I see.
So your slides should be in the system, right? Yeah. So if you haven't used this before, go here.
Okay, I see.
And then this one.
Yeah. Okay.
Okay.
So it's
Okay.
what is about the time?
At 5. So just wait a minute.
Oh, wait a minute. Okay.
Yeah. And there's forward and backwards down here
Okay, I see.
to do the slides.
I see. Is the keyboard working?
I don't. Some of the buttons don't work. So.
Okay.
Like most notably, the M key appears to not do anything.
I see.
Kind of weird.
Where's my watch? Oh, it's here. Sorry. All right. Okay. So okay, so it's 5 now. So should I start now?
Yeah, sure.
Okay. Okay. Hello everyone. Thanks for having me here. My name is Runglan, and I work for Sci-Fi Taiwan. Today, let me start this talk with this picture, the Odysseus and Polyphemus, which makes the title of the session. As a matter of fact, that we all know RISC-V is very much like the Greek world. They monopolize, meaning city-states running their own business. And there are too many extensions. A lot of them are proposed and ratified by individual test groups. Also, there are never too many IP vendors. They make their own RISC-V IPs, and a lot of them are equipped with their homegrown flavors. Either they are vendor extensions, specialized microarchitectures, or even bugs. Yikes. And here comes the million-dollar question. What and how shall we tell the user space about all these differences? What do we have here? The CSR, and vendor ID, and architecture ID, and implementation ID. Are these CSRs enough? Could be. Yet it requires a giant table to decode this kind of set into a specific vendor and model. So it shouldn't be the only information we pass through to the user space. And speaking of the ISA string, so will ISA string be enough? Well, there's something ugly that, the RISC-V privilege spec regulates the ISA string itself, changes from time to time. As you know, that there is some single letter extension, hypervisor extension H. It was put into the ISA string once and got removed. So even though RISC-V Foundation making clear that they won't touch the freeze ISA spec, but sometimes it changed. So this could break as well. And even though we had all this information included, different batches of exact model of IC with different manufacturing details could be different in the performance characteristic. So this is a mess. And all right, let's just pretend we're solving. Let us just blend all this information into DTB and pass to the user space. But by what exactly are we going to plumbing through this kind of information to the user space programs? Someone may say that we can use the proc CPU info. Well, there are a thing called Linux containers, and they don't like to mount proc FS for security concerns because it will expose the details. And even they let you use the proc CPU info. Things like LXE, the Linux container, want to put the facade on it to masquerade the information. So this might be problematic as well. So someone may propose to use the hardware cap. Hardware cap is will return an unsigned long type of information. So there's only 32-bit on the RV32 platform. That and if you want to squeeze out information, that will be a very long unsigned long. So that's not going to work as well either. So there are some roaming patches on the mainly saying that maybe we can use the hardware cap too. Well, another bit vector seriously, because with multilayer ISR string that this won't fit into another 32. It's just make the problem surface later. So we come up with this little bit drastic idea that we put the information to the VDSO data, where kernel pass the information to the user space. So even though it's only S390 using it now, but it's there, the framework is there, so we can define the architecture-dependent data into the VDSO data. And what's even better is that the ARC VDSO data is per core, meaning per hot. And there are existing RISC-V cores, such as the Starfire DAPE. It's heterogeneous. There are the cores, the hearts with the vector and the hearts without vector. So this could actually facilitate them. And here comes a very simple example. The mechanism is explaining. So when the kernel loads the ELF, it will put the hard information on the VDSO data and also push the hardware cap2 with the value of the start address of the VDSO data. So the user program could either use the VDSO function call or a system call backing up the VDSO function call, or even directly accessing the VDSO data with the hardware cap, the pointer that's stored in the hardware cap2. So here's the look and feel. Well, it's a little bit. Okay. Okay. I'm not very sure.
Yeah.
How do you zoom in like this? Whatever. Now I've broken it. There we go.
Okay.
I don't know how to.
Okay.
Sorry, I know. No idea.
Man, that's okay. That's okay. Well, so I'm just trying to show a very simple example that when a user program could use get actual value of the hardware cap 2, and then you can, if you know the layout of the video data, then you can access directly. So here's printing out the the extension and just the major and minor number, and the MARC and the vendor ID. And if in most of cases that in the user program, we just want to know whether extension exists or whether a specific version of the extension exists. So you can do a very propose a very simple VDSO function that will check whether an extension exists and return the version of it. And also, because it is a VDSO function, of course, you can design a system call backing up the VDSO function. So as a fallback, if you're using some kind of the MMU-less system, you can just use the system call. So the technical details that we can divide, just like I said before, you can define ARC VDSO data with the the emitter ID, MARC ID, and beneficiary ID. And this is just a proof of concept data structure that actually Palmer and Paul MC has proposed a much more complete, well-defined data structure. So I will bring it to the backups. And after that, in the parse DDP logic, meaning the boot sequence of the RISC-V platform, this function will be ran, and the VDSO data will be updated with the sorry, let me brace a little bit. It will update the VDSO data with the hard information. And so here comes the good, the bad, the ugly parts. The good, I think that the information could be free-form, even if you don't like what Palmer and Paul MC have proposed, you can design whatever you want, and using this plumbing mechanism, the information is per hard. And just like I said, there are already Starfire hub using the heterogeneous CPU cluster, so we can deal with that. So if you really want to use it on the memory list, I guess you can just get a system call and access it directly. But the bad part is that, well, currently I'm doing it in the DDP parsing logic. So if you disable CPU features such as the VPU, the vector processor unit in the runtime, the information will be mismatched to the hardware. So yeah, and the ugly part is that since you're trying, I'm trying to use the string compare to do the extension checking, but VDSO function doesn't have any single library support, so I need to copy paste the string compare into the VDSO function part. So this is the ugly part. And as Artich has reminds me that Plumber is more for a discussion, so I will leave all the detail on my GitHub repo, and you can go to the link with the slides. And that's it. Maybe it's time for ask what question. Yeah, please.
I really didn't understand what problem you have with sysfs, not procfs, which is deprecated, but sysfs. What's the problem with it? Also, you mentioned that you want to introduce a new system call. Why not? But that problem that's a lot of patching for something that IO control could do as well. No need for a new system call. And if you have a new system call on IO control, I really don't understand what the problem is with MMU-less systems. That would still work. So two questions.
Yeah, two questions, the sysfs part and the system call part. The sysfs is actually just like that's just like the procfs. Some content, there are environments that doesn't want to among these type of things because it was supposed to match too many informations, not just the the CPU info. So LXFS, the Linux container file system, is a fuse, and it will masquerade all this kind of stuff, not just the procfs but the sysfs as well. And for the system call part, well, I think you got it right. This is just kind of over-designed. So yeah, maybe we can come up with something more cleaner. Yeah, sorry. Yeah, please.
We need to use the mic. Got there.
Nice.
Isn't the VDSO actually mapped into the process
address space when the process is started. So that's the benefit of the VDSO, that the process can immediately access the data.
Sorry, could
So-
can yeah, just come again.
Do I understand it right that the VDSO data are immediately mapped into the process address space when the process is started? So
Yes.
the code can immediately read the HVCAP to
Oh,
when it is running without doing any open syscalls on sysfs, this kind of stuff.
yeah. If you yeah, that's the part of it. Yeah, because VDSO data is mapped to the process when the life of the process begins. So yeah, you don't need to use the system call. You can, and the hardware cap 2 is pushed to the users to the auxiliary vector at the beginning of the life. So yeah, you can access it during the C startup procedure to do some kind of like indirect function. If you have indirect function, you can access it directly without any support. So yeah, that's sorry for the interrupt.
That's convenient. Thanks.
Yeah, thank you. Please. Oh.
And Christoph, we have to.
So I have a question regarding that, and that is when we are looking at the specification, we also have architectural information which is not covered by the march string. For example, the cache block size of the CBO instructions.
Sorry, come again. You mean what is not covered? Sorry.
We have these CBO instructions which are operating on cache block sizes or on cache blocks, which have sizes which are implementation specific.
Yeah.
And they are not covered by the march string. How is this handled? And if we are looking at this in general, there is also non-architectural information, for example, fast unaligned accesses, which would also be interesting to see by the user space.
Yeah, just as I mentioned, that this is just a prototype, and you can just blend it into the DTV, and you can write the whole point here is that because the information is stored in the VDSO data, so if you know what's the layout, what's kind of the information being pushed onto the VDSO data, you can access it. So maybe you can design a special, maybe a DTS node to I'm not sure you're doing the cache block size. Yeah, so you can encode your cache block size into a DTS node, and you will be pushed to the VDSO data. And if you know that their information is there, you can read it out. This is not in the POC, but I'm sure it's very very easy to put it into the field. Yeah.
Yeah. So actually, I think it's off. Use this one. This one's on. Okay. Yeah. I actually have been messing around with some code, and I have a version of this that kind of matches this. It's more bitmap based than string based, which I think is something we need to sort out. But the proof of concept that I was using for performance was unaligned access speed. Right. So the idea is that getting the information that's in the isostring out to user space, that's kind of the easy stuff, because that's all defined by the spec and whatnot. But there's loads of information that we don't have in the isostring, right? So we sort of need our own format anyway. Whether or not we pass isostring also doesn't matter so much, right? Because we need to encode extra information, right? So the idea is to basically just have various key value pairs to encode information that's not encoded in the isostring, whether it's performance stuff or errata or vendor custom extensions that are sort of isostring adjacent. Right? They kind of all just go into the same bin, if that makes sense, right? And then that's it. Right. So the online access support, I tossed something in the DT for it, which is kind of clunky. I'm not sure it's the right place to get the information from, because then you're just going and modifying all the DTs. You're kind of just relying on that to be correct. But at least the user ABI, I think we can get something pretty stable for.
But if you mix it together with the march string, aren't you probably getting a collision later on with future extensions?
So in my proposal, there's key value pairs for each of these.
Okay.
Right. And
this one.
Yeah.
You can put a
right.
key
Okay.
there.
It's up here. Yeah. So there are distinct keys for the non
isostring components. And I'm actually providing some of the isostring components via bitmaps as well, under the assumption that those were easier to handle than strings in user space, particularly because like the isostring has changed definition over time. So if you try to just say it's the isostring, you can't really parse that without knowing also the version of the spec that that isostring corresponds to. So it starts to get really complicated. And we have a lot of isostring parsers like in all of our repositories, and they all have subtly different sets of bugs. And if you're like, if you know, this is UABI, so it has to be stable, right? So if your UABI is like, here's this string that changes every year, and we have to live with everybody in user space who parsed it how they felt like parsing it at that time, it's going to get very hard to maintain compatibility in the future. So that's why I'm leaning towards the bit vector stuff, because then at least, you know, we set a bit, we know exactly what it means, and in the future, when things change, we can figure out how to make it work.
So the key for each extension is different.
I actually have right now, I don't know, like, I don't really know what the right answer is here, but I just packed a bunch of extensions into a single key that were all defined at the same time. That seemed straightforward. But yeah, that kind of like fine-grained detail of how to encode the stuff, I think is best ways to work it out in the mailing list. I'm not super worried about that. I think the big thing is like, are we going to say we're just providing isostring to user space and then that becomes ABI, right? Or are we going to try to do something else that's not isostring based? And once we're kind of making up our own stuff, we have a lot of, you know, our own interface that we're going to carry forward, which is kind of a double-edged sword.
Irrespective of whatever we do, we still need the output in proxy info, isn't it?
Sorry, need the what?
Irrespective of whatever we do, we still need the proxy info output just for the users' perspective to know what extensions are there without using any tools.
Yeah, I mean, proxy PO info, I think, solves a slightly different problem, if that makes sense, right? Like, it's a useful thing.
Yeah.
One of the things I'm kind of hesitant in doing is providing information in only proxy PO info, and then you're basically making people treat that as like full-on ABI, parsed by a bunch of programs, all that kind of stuff. You don't want to be changing proxy PO info all the time, but I'm kind of hesitant to say, hey, that's the only place we're encoding a bunch of information. You know, live with it, because folks in user space will just go find the information where they need it. But yeah, I think like once we start to have an interface that's a little easier to reason about the ABI stability of, then we start whacking more stuff in proxy PO info because it's useful. Like, you just cat it to figure out what sort of machine you're on, that kind of stuff. Yeah, there's a question behind.
Since you mentioned the MMU-less systems, I wonder what's the current state of the MMU-less system and whether you use PMP for having per VDSO per process or not?
Or I'm a little confused. Can you say a little bit slower?
Yeah, the current state of the MMU-less RISC-V port. What does it currently protect, and whether you use PMP regions for the VDSO?
Yeah, I'm not sure if I understand your question right. You say that MMU-less system doesn't have VDSO data, right? Or did I get that?
How do you implement or map a VDSO per process? Do you use PMP regions or what?
Sorry.
Yeah, Damien's actually probably the right person to answer this.
Sorry, I wasn't listening. The question is, do you use PMP to do protection?
With MMU-less systems.
On the MMU-less system, there's no VDSO.
The only board I played with no MMU had a buggy PMP. If you touch it, the board just go boom. So I don't think it's used at all.
It was just on the slide. Okay, thank you.
So there's no protection.
Oh, it's no MMU. Come on, there's no protection anyway. So who cares? Application bug and you crash it.
So one interesting thing on how x86 does this with CPU ID basically is that CPU ID is trapped, and it's an interesting feature because when you do virtualization, when you run VM, you can expose different set of CPU features to your guest, and pretend that your guest doesn't support a set of features, even though your hardware does support it, or the other way around. And it's a very useful feature for cloud providers when they want to run a homogeneous set of virtual machines on top of an heterogeneous cluster. So I'm wondering if we're taking this virtualization aspect into account with that proposal, or even with the IXL proposal. I don't think we would be able to handle that kind of feature. Which is, I'm not saying we should do CPU-ID and specific instruction or anything, but the fact that CPU-ID is trapped by default on x86 provides this interesting feature.
Yeah, I mean, this is basically a CPU-ID syscall or VDSO entry point or whatever.
Mm-hmm.
It looks almost exactly the same.
Actually, during our kind of discussion with Palmer, we at some point we think that we can provide a pseudo CSR or things like that or even a SBI call for the for the upper layer of the system to query this kind of things, but because you can just because it's provided by currently it's provided by DDB, so maybe if you're a hypervisor, you can provide a fake DDB.
If you're an hypervisor, you in many cases you actually don't have the luxury of the guest is going to use a full-blown image coming with a DTB or with an ACPI description or with a full-blown firmware. So the advantage of the trap and emulate approach is that you can dynamically configure your VM through your hypervisor to say I want my VM to see this specific set of features and nothing else, regardless of which image it's running and which DTB or ACPI tables or whatever.
Yeah, that makes sense. So we don't have anything in the ISA to probe stuff. Probing is all external, so we need to add a bunch of stuff for that.
Yeah,
it's a sensible use case. Yeah.
I'm just calling out for it.
Yeah.
I think it's a sensible use case.
I think it's just going to be a big uphill battle to get that in the ISA.
maybe not in ISA, but the as part of the specification make it. I mean, I don't know, something that we could trap from the hypervisor.
Yeah. So right now we have which are firmware calls. Exactly. But if you're worried about too much of the firmware coming along with the guest image, then you're kind of hosed. Yeah. So I think if you're really worried about guest images that come with their own firmware and are kind of ignoring what's below them in hypervisor land, then the only way to deal with that is some sort of instruction that you trap.
Hey, Palmer. Yeah. Palmer, can I add some info?
Yeah, fair. You could
hey, Palmer. So in context of KVM, actually, Palmer, can you hear me?
Yeah.
Yeah. So in case of KVM, it's or in general for hypervisors, it's not just about detecting or showing a particular set of features to the VM. It's also about providing the ability to the users to disable also certain extensions using HENV config or SM statin. So it's like a configurability of the features as well when it comes to hypervisor, right? So at the moment, or at least how it's done in different articles and how we are doing in RISC-V as well for KVM, is that we have this standard ioctl interface that one reg interface through which we are showing the features that we can virtualize, and some of them can be also disabled as well. So using which, if there is a heterogeneous cloud, so administrator can come up with a common denominator of the features for the VM, and then the migration will work across the heterogeneous machines. So it's not just about detecting it.
Sorry, go ahead.
Yeah, go ahead. Sorry. So it's not just about detecting the features; it's also about the ability to disable some of them, right? So in case of hypervisors, right? So.
I'm not really sure. Okay, so I don't know if there are any more questions.
For the VDSO format, what I understood is that like 2 of them are in floating, because slide was showing 1 and there was a Google Doc link, or are they same?
The slide. I changed the slide a little bit, so this is the newest version. So it will have some backup slides like the Palmer's proposal. So it's a little bit different than the previous one. So Is you asking why the slice is different?
No. I was asking the VDSO format that you implemented, the one you showed in the slides, and there was a Google Doc link. Are they same or different?
Sorry. Okay.
Yeah, so Atish, there's like a bunch of different proposed encoding formats in the various slides.
Oh.
And there's a couple of different copies of the slide set.
I see. Okay, we want to discuss the format, or are we going with the key value?
I mean, we can talk about it if you want. I am really
let's-
bad about like bit encoding in person. Like to me, that's very much a mailing list thing. But yeah, sure. Like, what do you want to talk about? We have a few minutes.
I'm not seeing the format, so there's like we have still 10 minutes. So if we don't have any other questions in the room,
Yeah, Jessica.
There we go. Yeah, I had a couple of points. The first one was you said that having it be per hot was a feature, and in some sense that is because that gives you more information. But for most code that just has ifunc resolvers in plain C, it's not trying to pin to CPUs, it's not trying to care about what heart it's running on. So having information that's potentially incorrect for CPUs it may later be scheduled on is actually quite unhelpful. And you'd really like just a summary of what can I assume for my generic C code. Is there provision for having something that is just, this is what you can assume without doing anything special?
Yeah, so I have a syscall, which may not be the right way to get the information to user space. Sorry, but the reason I did the syscall is so it can take a CPU set T or CPU mat, whatever, the same thing all the scheduler calls take, right? So you provide that, and then it tells you what's on all of the CPUs that are in the set that you gave it. So if you have pinned yourself, you can very straightforwardly ask, and if you have not pinned yourself, then you just ask for everything.
Sure. And then the second one was, obviously this is a Linux Plumbers conference, and this is very Linux focused as a result, but other operating systems do exist, and they're going to have to solve the same problems. And it sure would be nice if everyone had the same interface, so we don't have to have if-defs everywhere in all our software. In the AR64 world, everyone's sort of settled on the hardware caps. In the x86 world, you can just use CPU ID. It would be nice if, despite whatever underlying mechanism exists for whether it's a VDSO or a syscall, that there was some slightly higher level, not very high level, but a C function that you can just call, for example, that will provide an interface that other operating systems could implement.
Yeah, both the ARM and x86 ones are pretty grounded by the ISA. Yeah, the ARM stuff basically just passes through whatever control registered map that they have for this stuff, and x86 obviously is CPU ID. So it'd be really good to have something so everyone's not just making up their own thing. That seems reasonable.
Yeah, I mean, and previously, we can back it with a syscall rather than a magic VDSO, or we can put it in our share page. Doesn't really matter, but just having the API is a well-defined thing that's slightly separate from the OS.
Yeah, I think the mechanism by which you get to the information from user space is not super exciting, right? It's like, what is that actual bit encoding of those tables?
Yes, and I think there's a slight conflation of the two in this talk at the moment that I just would like to make sure that we try and tease apart as the discussion goes forward.
Where there?
So you have a race.
Oh, no, but that's just Jessica still.
The Google Doc link shared in the slide doesn't have access. So if you can give.
Okay, maybe that's confusion.
I'll fix that.
Yeah, so
All right then. So I guess there's no other questions. So maybe we can end this early, or
sure. Yeah.
Okay.
Your talk. You spent way too much time talking. Okay, so I guess, yeah, Sunil's in 7 minutes. So, I don't know, just wait or something. Unless Sunil wants to start early.
Can you hear me?
Yeah.
Okay. I can start early if you want. Otherwise, I can wait also.
Yeah, I mean, I'm not supposed to start early. There are other conferences folks come in from. I don't know what people mostly do. I never swap, but I don't know what normal people do. So, I mean, I'm okay with just starting early. Just we almost always end up running out of time in someone's talk, so might as well just go for it. All right, yeah, let's go for it.
Can you tell me how do I bring my slides into this? Atish?
Yeah, there is a button on your left. I think Pamar is doing it.
Okay, thanks.
A plus button where we can switch slides. Yeah.
Plus button in the bottom left-hand corner, then you can just pick your slides.
Okay, thanks.
Yeah, and then
We see only the penguin. Oh, now it's better.
Yeah, I think it was zoomed out. Okay, shall we start? Okay. Last year in the LPC, we had provided overview about what we need to do for ACPI support for RISC-V. And in this session, we will directly jump into the updates, what we have done so far. So my name is Suril, and I work for Ventana Microsystems. And basically, this work is done in multiple groups, and I'm just representing here all of them. So here is the agenda because it's plumbers. I'm keeping it very short. So first of all, before we jump into anything, what are the platform requirements or hardware requirements to support ACPI? We will discuss that. And then UEFI or ACPI forum follows the process called engineering change request or ECRs. So we have several ECRs which are to be reviewed, and we will discuss about the status and the plan for the basic support. And also we discovered necessity for a new UEFI boot protocol to support ACPI for RISC-V. So we'll discuss about that. And finally, we will discuss about some of the how do we go about upstreaming of these things. And there are some advanced features. When I say advanced features, the first thing we are trying to do is basic discovery and boot support of ACPI in all these ECRs. And there are some features like power management or IOMMU, which are still in work in progress kind of thing. So we'll discuss what we are trying to do in that functionality kind of thing. So regarding platform requirements, basically it is planned to be supported only on 64-bit platforms for obvious reasons. But important thing is it is planned to be supported only with advanced interrupt architecture of RISC-V, also known as AIA. Primarily because ACPI is targeted for server class systems where MSI interrupts are necessary. So AIA provides the IMSIC or MSI controller, incoming MSI controller. So that is mandatory to support ACPI. Also, AIA provides APLIC, advanced platform level interrupt controller, which is an optional features, but basically it is required to convert wired interrupts into MSI. So if the platform needs to support wired interrupts, APLIC is necessary, but it is not mandatory to support ACPI. So with that, we'll directly jump into the ECRs. So because EIA spec is not yet frozen, we kind of divided these ECRs into two batches. The first one is whatever is already ratified, or there is no dependency on any specification being frozen. So these two ECRs basically, first ECR is adding the local interrupt controller information in the MADT table of ACPI, which is known as multiple epic description table, where each interrupt controller information should be populated so that operating system can probe and install the driver. And this is a per processor or per heart interrupt controller, and it also provides the ACPI processor ID to the heart ID association. And so this basically doesn't have any dependency on AIA. And the second thing is, like in the previous session, we discussed so many extensions are there in RISC-V, and in the ACPI specification, there is no existing mechanism to pass that kind of extensions, ISA string, etc. So um, we are proposing a new table for RISC-V RHCT, and it provides primarily ISA string as well as the extension related information in future. For example, CBO needs to pass block size, etc. So that also will be provided by this table along with the time-based frequency. So with these two ECRs, we are able to boot Linux with polling mode, SBI console, and RAM disk. So I mean, for the proof of concept, this is functionally complete, but it may not be useful feature. I mean, useful in a complete way. So in the next batch, we plan to submit the ECRs. I forgot to update that the previous batch is already submitted to SWG or UEFI forum for review, and they are reviewing. And based on the feedback, we will modify that and get it approved in the ACPI forum. Atish, I think you raised a hand. Is there a question?
Yeah, in the RSCT proposal, do you have the CBO size? That one is there or it's removed?
No, currently it is removed because there was some work pending to finalize the things Aaron wanted. So that's why it's pending. It is removed in the first version of the RHCT. In the next update, probably we'll add CBO related stuff.
Okay, yeah, that makes sense because that thing is still undecided. So
yeah.
So more precisely, the clarity required was from the profiles actually. If profile comes up with a unique way of naming this CBO size in part of the ISA string, then why not use that rather than defining a new entry in the RHCT table, right? So we are still waiting for confirmation. So this can be always done as a separate ECR, right?
okay, is UEFI forum okay with like bunch of small ECRs?
Yeah. As long as we update the revisions of the table, they're fine. Sorry.
Okay, does the hard capabilities table also provide the information we talked about in the previous talk, these key value pairs about the extended features?
Right now?
No, it is planned to support only the ISA string to the kernel, right?
Not right now, but one of the hopes is that that would fit really well into ACPI because it looks a lot like ACPI. That'd be a very natural place to have the spec owned, so it's not just a UABI thing, because that's very similar to what all the other targets do. Right? They have a hardware-looking table they pass through. You can just keep. All right, we're ready.
Okay. Okay, so moving on, in the second batch, basically once AIA spec is frozen, we plan to submit these ECRs. So basically we will update this RINC table, what we submitted in the first batch. with the per heart IMSIC base address and size, and also add the IMSIC and APLIC information in the MDT. And also APLIC being a platform device, which basically is required to convert wired into MSI, which requires MSI services from the IMSIC. So this APLIC device needs to be populated in the namespace, something similar to IOS-APIC. And we need an ECR and dedicated APLIC ID for this. So that is another ECR. And finally, for NUMA, each processor's proximity ID needs to be communicated via a substructure in the system resource affinity table, SRAT. So that is also we need to add one ECR for that. So these are the ECRs, and basically we are finding challenging with these timelines. We don't know when some of this spec is being frozen, so that's why we are splitting. But if things work out and AIS spec gets frozen, probably we'll combine these two even before ACPI approves the ECRs. We'll see how it goes. Usually they will approve quite fast, but let's see how it goes. Okay, so one more thing we discovered last year was the necessity for a new boot protocol. So primarily, mainly because I think this was brought up by Jessica last year. So traditionally in RISC-V, the boot heart ID is passed as the first argument to the kernel. But in case of UEFI platforms, the calling convention of EFI doesn't allow that. So we needed a way to pass this boot heart ID to the UEFI systems. There was one solution already available from Atish, which was upstream, basically to pass the information via DT. But for ACPI, parsing the ACPI table so early was difficult, as well as it was not a good design to parse ACPI within EFI stub kind of thing. So I mean, modularity wise. So ARD suggested to implement a new boot protocol for this. So currently it is just providing the boot heart ID, but in future this can be extended if there is some more information which needs to be provided via this protocol. So this specification is maintained within the RVI, and UEFI spec updates. UEFI spec basically provides link to the specification maintained in the RVI for RISC-V platforms, and this specification is ratified this year, and the support has been added in the U-boot as well as Linux. EDK2 support also is in progress, pending for some refactoring work, and you can find the specification in this link. Okay, so now, sorry, go ahead. Is there a question?
I don't think so.
Okay, thanks. So now, I'm getting an echo. Okay. Basically, one of the challenge I see is just last month there was a version of ACPI specification released. So even though ECRs get approved, it will take at least a year, I feel, for the next version to be released, or more than that. So the challenge with this ACPI spec is these ECRs are reviewed within the ASWG forum where not everybody can access, and public released ACPI spec will take a year. And also once this ACPI spec is released, some of this MDT table information, etc., needs to be added into a ACPI CA repository. Header file patches need to be updated in that, and then that has to be integrated into Linux, I think. So all this look very long journey. So I am looking for inputs, how we can do something early, whether we can send some RFC patches, because some of these patches in Linux are based on ARM architecture. A lot of hard work was done for ARM architecture to enable ACPI. That's why a lot of things in RISC-V to enable ACPI are much simpler. So, but whether we need to do any refactoring or some of those things, I was thinking some early inputs to the RFC patches may be good even before ACPI spec get released, but I'm not sure whether that is possible.
So you don't need to wait for the spec to clear. This is not what Intel does for its ACPI changes. It tends to get them upstream in parallel with getting them in the spec. So I'd say you pick a point in your process, probably either pre-ECR or just coming up to ECR, start doing the patches in parallel with that. So that means that by the time the spec hits, the patch should already be upstream in Linux.
Yeah, and like to first order, that's also how we do the RISC-V Foundation specs. Like, the reason we do frozen and not ratified is that getting something through like the official process for any specification could be kind of an arbitrary amount of time. I don't know ACPI very well, but at a certain point, you know it's not going to change anymore. And that's the point at which we can take stuff. It's frozen for RISC-V. I don't know what all these words are for ACPI land, right? But if other architectures have a bar at which something's good enough in ACPI that it's ready to go, then I don't see any reason we need to do anything different. That makes sense.
So
and the other thing I want to say is like you can always send an RFC, like just send it. Like it doesn't need to be fully done specifications and whatnot. Like you're better off just sending it early so folks can read the code that goes along with the specs, and upstream folks will read it and whatnot. That's the good way to do it.
Once ECR is approved, there is no way changing the spec, right? Is that correct?
Yeah.
So we can consider that as a freezing point, like that as a point to be patches to be accepted.
Well, both ACPI and UEFI are supposed to be code forward specs. So in theory, code is supposed to be available as you get the ECR approved. And what better to try RFC code for than Linux? I mean, what's the worst that can happen? They piss all over it, they don't like it, so you have to repatch it. That's all that can happen in Linux. And you mostly own the architecture. So I'd start patching first in parallel with doing the ECRs.
Okay, yeah, I guess my worry with that kind of stuff is just when there's an external specification process, I don't want to make a mess and then end up with something that's a de facto ABI that doesn't match the spec. You know what I mean?
Right, but remember the specs are basically a reflection of what people think. If you code ACPI without actually trying to implement it, you often find you've made a cock-up. So coding it in parallel with the implementation helps ACPI actually be correct first time out.
And that totally makes sense. Like that's like, I think to me the question is like, when do we merge the code, not when do we write the code?
Ask yourself what the harm is in merging the code. Even if ACPI says, actually, you've forgotten about this bit, we need to modify that, you can patch the code as part of the process of doing the modified ECR.
Yeah, I guess.
So you can evolve the ECR and kernel code in parallel.
Yeah, I guess my worry is just like, then you have kernel code that looks at the old version of the ACPI stuff and will not function with the new version, depending on how it changes.
Yes, but you don't mark it as people can rely on this in the kernel until you know that the ECR has been approved.
Okay,
and that's still way before ACPI publishes the spec.
And there's a way to do that in kernel land. I don't know ACPI that well.
Well, it depends. If this ACPI thing happens to be an ABI that people rely on, then you just mark it as experimental until the ECR gets approved.
Because usually it's just, when it's upstream, it's ABI and we're set. If that makes sense.
No, upstream is not as hard and fast as that. We know certain interfaces have to be evolved as they're first created. We never get anything right first time round, for God's sake.
Yeah.
So it's a complete myth that what we put in first time round we have to stick to for all time.
That's great. As long as ACPI works that way, that's fine with me. I just don't want to make a mess.
Well, ACPI doesn't quite work that way. It likes to think of itself as the oracle for everything. But this is the way evolving ACPI should work.
Okay, all right, yeah. Well, if that's the way other people are doing it, then I'm fine with it. I just don't want to because if other people are not treating it that way and we treat it that way, we get in trouble.
Yeah, Yeah, the only other people are Intel. They own the specs, so they're perfectly happy putting stuff sort of upstream early because they have pre-approval effectively to get.
And that was my
ECR
worry,
done.
right?
You need to work on a more experimental patch forward basis
Yeah.
because you're not Intel.
Yeah, that was my worry, is that we live in a different world. So anyway, okay, cool. Yeah.
So how much time usually it takes for an ECR approval?
It depends, I think. So if it is simple and not conflicting, I think they will approve in one meeting.
Is it like a monthly meeting?
It's a weekly meeting, but last 1 month, because of summer holidays, people took off, so it did not happen. So this week probably they will review this.
As per my understanding, there is no mailing list where it's being discussed, right? It's all in-person meetings, correct?
There is a mailing list, but which is closed for UEFI members, and I mean it's a closed group, as well as there is a something like Jira ticket tracking where we create these tickets and submit the ECRs.
Thanks.
Yeah.
I have a in-person question. Have you gotten good engagement from the Windows folks on what you guys are proposing? I feel like they're sort of often the other interested party, and probably the only other folks that would come back and be like, "Hold on, we don't have what we need," and would probably ask for major changes. So, have you talked to them much at all, and do they have any feedback on what you're doing?
No, we haven't talked to Windows guys, but some of these things are very basic things what we are trying to enable, and it doesn't deviate from other architectures what they have done. So
You're not
I think,
expecting much trouble, is what you're saying.
yeah. Even if they have some new improvements, I think we can update with further ECRs.
Okay, thanks.
Okay. So in terms of some advanced things, we are working on the IOMMU, ACPI table for IOMMU support. That is still work in progress. And for power and performance management, we are working on the fixed feature hardware specification for RISC-V. Every architecture needs to maintain this, and this will be maintained and ratified within RVI. And this is required to support LPI, low power idle, and CPPC for performance management. So we are working on this, and yeah, so I think yeah, so these are multiple groups from which we are getting a lot of inputs, and currently all these ACPI discussions have been moved into under RISC-V platform runtime services TG, and there are a lot of people within these communities who have provided the feedback and helped in this ECRs. And here is the GitHub where if you have any issue, you can raise it, and question also you can raise it there. And if you are a member of RISC-V, you can reach out via this mailing list. With that, I think let me complete this. Thank you very much. Open for questions.
I don't know if there are any in-person questions.
Okay. Yes, Jessica.
You guys want on the computer?
You said you had version 2s of various tables to follow on from an initial version 1 that's sort of basically useless, but sort of gets the core of the architecture strings in. Are all those version 2 changes backwards compatible with version 1?
Yeah, it has to be backward compatible, any version 2. So basically the fixed offsets in the previous version of the table cannot be changed. So only additions can be done.
Okay, and has that caused problems for your version 2, or do you anticipate that potentially causing problems in that had you just waited to do version 2 as version 1, you might have got a nicer table design? Or have you tried to design them so that version 1 is basically version 2 with stuff taken out?
Yeah, usually it will be version 2, it will be the latest. Did I get your question?
As in, no, there is a risk that if you try and do backwards compatibility, you end up with a worse API than if you do a breaking change, because you have the constraints of not changing the layout of what's already there. And so there is a risk that by sort of trying to rush ahead with getting version 1 through, that's not really actually ever going to be used in a real system because it doesn't have anything that everything that a real system would need. There is the risk that you'll end up with version 2 being a worse thing than if you just skipped version 1 entirely and designed version 2 from scratch. So my question is, have you designed, has your approach been define version 1 and then add on top of version 1 what you need for version 2, or has your approach been design the whole thing from scratch and then take out the bits you don't need for version 1?
So basically, that kind of thing, what we are doing is with respect to the INT-C table, because AIA is not yet frozen. So version and version 2, the difference is only the IMSIC base address and size, which are additional inputs compared to the version 1. So there is no removal of any fields. So that way it is always backward compatible. And these versions are not new in the ACPA world. There are many tables which have gone through the versions, multiple versions actually, and we just need to maintain the compatibility.
In the heart capabilities table, do you anticipate that having
Yeah,
to be awkwardly extended, or do you anticipate that being a clean extension once you resolve the various issues that you're facing at the moment?
Yeah, so hard capabilities table, we anticipate it will grow multiple versions, but the way we have designed is it is easy to add or add the new features into this without breaking the compatibility. So we don't anticipate it to break the compatibility, but it will allow us to add more features in future.
And so what do you do for CBO at the moment then? Because there needs to be a way to distinguish between version 1 CBO and version 2 CBO. If you decide that you need to encode the block size in there.
Yeah, so every structure or substructure within the RHCT has a version. So basically, for each different extension version, the different subtype of the CBO will be there, and we don't need to maintain both the versions within the RHCT.
Okay, so it's not just an ISO string.
Yeah, it's not just an ISO string. Yeah. And this is primarily influenced by the PPTT table, which follows the same architecture. So, so we are following this something similar, and it is extendable for future also.
Okay, thanks.
I don't know if we're going to talk about this later, but what's the status for AIA and for also IOMMU?
Anup, you want to answer?
Yes, let me try to answer that. So AI, I mean, is right now in officially stable state. It means that we got approval from the Arch review committee, and so now it's just 1 or 2 months away to reaching the public review. So we hope that it will be in public review like in just 1 or 2 months itself. So once it is in public review, it means that it's frozen. Okay, and the rest of the ratification is just following the process and get it out released through the proper completing the process, right? So the same applies to IOMMU as well. So that also has received an Arch review approval and all those things. So it's in a stable state, honestly. So both of these things, quite optimistically, will be like in a frozen state by December, let's say. That is, yeah, or it could be earlier as well, right? So
And like, at what point in that timeline do you think Linux like patches would be like attempted to be merged?
So Linux patches we can send any day, but we are just holding off just to make sure that things are always frozen when patches land. But yeah, if people want, we can send RFC patches for AI at least sooner. IMMU, it is still some work going on to complete the some bits of the proof of concept. But yeah, maybe Atish knows a better state on that. But I think those can also land pretty soon. RFC patches, right? So.
Latest I have is that IOMMU will in fact go to public review this month, and the AIA shortly thereafter. So there's not a big pressure. These are non-ISA documents, so it's not like a huge pressure to get into a profile or something. And we're going to do the right thing for RVI members and make sure that they're in place. But also take a look at the size of IOMMU. It's a 90-page document. So I expect the public review is going to have some comments. AIA is a lot shorter.
And towards the end there, you had the newer groups up there, and I know recently we went through some changes in how things are organized. So the one that's handling the ACPI, is that the PRS? Is that the Platform on Runtime Services? Is that the group?
Yes.
Okay. Yes. And then is SBI under the OSA SEE task group?
No, so Platform Runtime Services will drive both SBI, ACPI, and UFA. So for now, there is no pending proposals in UFA land, but ACPI and SBI will be discussed actively in the PRSTG. So OSSE is basically like a overarching spec, which will include all the interfaces and some other things, including profiles. So, and then it will basically a software guide or software spec for distros or other folks to follow, like to make it compatible across platforms.
Okay, so is profiles going to come from the OSA SEE task group? No.
I'm Mark, by the way. I mean, Drew knows me, but I'm the CTO for RISC-V. So we just did a big reorg inside of RISC-V. There's now a Priv software committee, and they're just getting their feet on the ground and organizing things. There are some recurring specs that we're updating every year, UEFI, SBI, blah, blah, blah. And that's what PRS is about, is handling those, right? The SEE, you got to go back to the unpriv spec, to the priv spec. And SEE is a term, supervisor execution environment. And there is an API between the kernel and it. Supervisor execution environment, it's all the things that the kernel needs in order to run. And so it includes profiles. Profiles are actually driven out of a profiles task group that's separate and is run directly by the technical steering committee and not by the privileged software committee or anything like that. So profiles are all about ISA, and they're in public review right now for Rich OS. But the OSA SEE is, as was said, an overview document, and it has its own task group that's going ahead and pushing that forward. Does that answer your question, Drew?
Yeah, I'm also wondering, where would the platform specification fall?
So there's an action item for the new privileged software committee to actually define what's in a platform spec.
Okay.
Until they do that, it's nowhere. Once they do that, the profiles and platforms, because they are sort of fundamental to RISC-V members, they're both run directly by the technical steering committee, although they're sponsored by the ISA committees for the profiles and by the privileged software committee for platforms.
Okay.
I'm sorry if this is just rattling the stuff off, but there are org charts around that explain all this, and we can show them at some point or send them to some email.
Okay.
But they're readily available.
All right. And then the one last thing. So Atish, you're the chair of the PRS, is that right?
Yes.
Okay. And you had the first meeting, was it last week?
Yeah, we had the first meeting last week. That was just an intro to figure out the time slots and logistics, everything. And then we'll have the next meeting next Tuesday, I believe. I'll send the emails.
Okay, thanks.
And thank you, Atish, for doing that.
We have 2 minutes. I don't know if there's another question. So I guess we're on to Connor.
We are finishing our talks before time this year, so I don't know if it's a good thing or a bad thing.
Well, I think it's only 2 minutes.
I think like we're only ending 2 minutes early, which I think is pretty reasonable. It takes about that much time to get folks moving around anyway.
Yeah, absolutely.
Need that long to figure out how to click on all
No,
this stuff.
like all the previous years, we always used to run over the time slot. So
Yeah, but I think some of that's that we've been pretty hardcore about the do discussion as part of your talk thing, rather than give it
100
20 minutes
slides.
talk for 20 minutes afterwards. So
It's back in the.
yeah, you can click the full screen.
Cool. So I only have 3 slides. So hopefully get through the 3, and then some people can tune in with opinions, because I guess I have a problem, and I don't particularly care for a particular solution. So yeah, pretty much this came up because I sent some patches trying to make changes in kconfig.socks and the def config, and Aaron pretty much shut them down as, oh no, you can't make those changes. They're not really what's the policy, I suppose, for kconfig. And so on asking, oh yeah, what is the policy? It became it was pretty ambiguous. So I went into this going, oh yeah, let's maybe come up with a policy that does make sense for what we have, and kind of sort them out. So just for a little bit of background, what we have at the moment is we've got 5 entries in kconfig.socks. We got 4 real socks and the vert machine. The symbols are all named sock _ something. So we got the sci5 and star5 ones, which are not really socks. They're more groups of socks, I suppose. And then microchip stuff, yeah, it is actually it's named after just one sock. So it was Palmer's original goal for this stuff was, oh yeah, I want like a straightforward, like an easy place where people can just turn on one symbol and they'll get all the drivers, whatever, enabled for a given SoC. But at the moment, nobody's symbol does this. And people who are coming over from ARM or whatever, that's not what they're expecting to do from the ARM side. If we were to do this as well, there'd be a whole bunch of, every time someone's turning on as a new driver, they want to be coming on, like adding a new select or whatever. So things would bloat pretty fast and overload already overloaded maintainer. So, and then one last thing that was pointed out, I think by Andreas Schab, was that if you do select things, it'll override someone who's already set something to be a module, which I think was a problem for him with the QEMU OTC driver.
Yeah, there's also an issue with the selects. There's also issues with selects where it will
not select the dependencies, which we run into all the time, which is super broken.
Yeah, I think as well is sometimes people go around reorganizing, changing symbols around in different driver subsystems. They wouldn't be aware that, oh yeah, I also have to go and like fix up the selects, and then things end up getting broken.
Is this a problem on other architectures?
Well, other architectures do it a bit differently, I suppose. So not the same problem for them.
So one of the ways you can do it is with menu select, which is not like select. All it does is it gives you I want to select 1, 2, 3, 4 of these config menus, and then it will give you another menu and saying that means do you want these set of drivers, and it will just show you the defaults for them. So it doesn't really help you overcome the selection problem, but it helps you overcome the grouping problem.
Yeah.
I guess like with like
other like driver tree symbols inside an Arch RISC-V menu select? That okay, that might be.
You'd have an initial menu first that would say, sorry, you'd have an initial menu first that would say, what SoC do you want? And that would select one symbol. And then you'd have menu selects that say, if this symbol is defined, then show this menu. Otherwise, if this symbol is defined, show this menu, and so on.
I was going to get a bit later, but the Renesas guys who are coming over to RISC-V, they do that in their SOC, driver/SOC, whatever, KCON there. They have that kind of, oh yeah, like Arch and ASAS would do one thing, and then you can go select different SOCs, turn on all the stuff for that one SOC there. So they're kind of doing that sort of thing already.
Okay, well, it sort of works.
Sort of.
And it doesn't get you into the select problem, and it won't override a module selection.
Yeah, you need the mic.
It doesn't get you into the select dependencies issue that Palmer outlined, and it won't override a module selection unless it will still show it in the menu, and you can override it manually, but it will show you what the default is.
Yeah, because I think my main goal was just like when users show up and they just say, hey, I want to run on this SoC, they don't know which drivers to select, and they're just scattered all over the tree, and they're not all necessarily related to the SoC or the RISC-V or anything, because these SoCs are coming from elsewhere and picking up drivers and IPs and whatnot, right? Oh, great, yeah.
So in general, using select in kconfig is just asking for trouble. Use it as little as you can. The way we deal with this on ARM is like we have a couple of older SoCs that still use select because they always have. What works better is that you flip this all around. Like you turn in the dev config file, you turn on all the drivers for all the platforms. And then you make all the drivers depend on the specific SOC platform. So if you're building a kernel for a particular SOC, you start with the dev config and then you turn off all the other ones, and that turns off all the other drivers. That tends to work a lot better once you get to more than 5 SOCs.
Yeah, and one of the problems with our current approach is that a lot of driver developers assume that that's what we're trying to do and encode the dependency logic. So you get in this weird spot where sometimes the setting in the SOC thing will turn on drivers, and sometimes you have to set it on to turn on drivers, and it just doesn't make any sense. So it's a mess.
Mm-hmm. The only subsystems that actually require you to select drivers, I think, are clock source and IRQ chip. So because the platform maintainers decided a long time ago that they do not want to offer all the drivers, they only want to have the drivers selected by the platform. So they are the special cases.
Also, an interesting question would be SOC-foo or Arch-foo, because, for example, the Allrunner D1 has existing precedents. There is Sanxi drivers all over the kernel depending on Arch Sanxi, where on RISC-V we are currently SOC-foo.
Yeah, I think we should do the same thing. There's no reason to go change a bunch of code. If we can change one line of code, why go mess with everything?
My preference as well. Like
yeah.
for that, I was going to say like it would make the most sense just to go no, like why are we different with SOC and just take the Arch thing and just do
I think it's what I think when we had the kconfig SOCs at the beginning, it's because I didn't really know what I was doing. It's the best I could come up with, so it obviously doesn't work. We've known that for 2 or 3 years. no one's had the time to sit down and actually say, yeah, let's fix it, partially because we really haven't had that many SOCs, so it hasn't really been a concrete problem. But there are more coming now, and it's gonna just make a headaches for everybody for no reason if we don't fix it. So just do what ARM does. Like, why mess with stuff?
Yeah. So that was the next thing I was gonna say. Is like,
so I just wanted to add to the first question. Is it possible to use the imply kconfig keyword somehow to imply you want some drivers on the architecture level?
Yeah, I think people suggested that before, and I've not found anything that like that helps with. if that makes sense.
So Ubud is using it extensively, and I believe it is actually using it for this purpose in kconfig.
Okay, interesting.
That might be a good example.
Okay, yeah.
So imply is pretty much the worst. It combines the downsides of select and depends on. it's possible that U-boot still has the old imply, so we changed the meaning of that keyword a couple of times. What it currently means is something gets turned on if you're running make dev config, and otherwise it has no effect. So it only turns it on if the symbol is not already set, but you can still turn it off, which has almost no meaning at all. Please just don't use it ever. We should kill it from the kernel.
What are we supposed to use? To get back to the SoC foo or versus Arch foo, so I think the original reason for that is that on ARM64 there was a restriction on a single symbol per architect, per vendor in the main kconfig file.
Yeah, and we really, really didn't want that, and that's why it has a different name, because giving it a different name made it look different. But I think that has stopped happening elsewhere, so we don't have to worry about that anymore.
Well, for the Renesas devices, so now we have the issue that Arch Renesas is being used for ARM32 and for ARM64, and since the SoCs are basically ARM SoCs with the ARM core replaced by RISC-V, it's easier to keep the Arch Renesas on RISC-V too.
Yeah, I agree. But what I didn't want was, have Arch vendor A and Arch vendor B be impossible to turn on at the same time, and those things used to happen in ARM land. My understanding is a lot of that's gotten fixed.
But that was 10 years ago.
Yeah, but remember, that's kind of when we started this stuff.
Okay, fair enough.
It just hasn't gotten fixed. It's been broken for a very long time. So. Yeah, I think we don't need to worry about that anymore. So, like, no reason to change the name just because of that.
Let's go back a bit then. Is the kind of like it sounds like you're saying, Palmer and the sort of others, that doing the kind of default using in the subsystem, whether in the kconfig symbol in the subsystem to do default sock/arch underscore or whatever, and take all that stuff out of kconfig.socks and just turn on the subsystems themselves. It sounds like what's being put forward.
Yeah, I think kconfig socks can go away entirely. We need those arch symbols from somewhere. If I remember correctly, they're in the ARM, Arch ARM kconfig.
We would have to redefine them.
Yeah, so we'd add those into our kconfig or arch list, or I just do the same thing that ARM's doing, and then drop kconfig.socks, and then deal with the fallout of some drivers aren't on anymore or whatever, and sort out the def configs.
What ARM has is ARM is like kconfig.platforms. It's the same thing as kconfig.socks.
Yeah.
So it would just be we could just keep the file.
Yeah, just rename everything. It's the same thing. Yeah.
So then, what about things like the plick? Where we should just turn on the plick anyway? Like everybody at this point, there's non-sci-fi based things using the same driver.
So that's kind of a different problem. The plick was not a RISC-V spec, so we thought it would not be like the base of all of the other intercontrollers as well, but that is not the case. So again, right? Yeah, I think probably just a historic thing. So
it is also being ratified this year.
Yeah, Mark said it's being ratified this year. So
what about the special case?
Damien.
What about the special casing for SoC? I'm talking about my toy stuff that requires the tiniest possible kernel. So you really don't want to have random stuff being enabled and then go through it and then remove what you really don't need.
I think I think I had on one of the earlier slides. I might have skimmed past it, but like it's the Canaan board is like it's a special thing. They're a special case. They already have their own like straight up def config. They already have their own like handling with the built-in DTB stuff as it is.
Yes.
So I would be in favor of keeping as much of that as it is as possible.
Yeah, I mean, the command won't work if you turn on every driver.
You won't be able to load it, so
Yeah.
it could work. You just not enough memory to load it.
It could still be renamed to match the others, but it would be.
I don't care about the naming. What I don't want to end up with is, again, you do a make canon, whatever the name of the config, I forgot, and have to do a make menu config and go through and remove what you actually don't need. Because that's actually harmful because it makes the kernel too big.
I have no interest in going near that well.
So that's what I don't want to happen. So yeah, I don't care about whatever changes as long as it just keep working as it is.
Like we'll probably have some def config fallout, right? Like we will try to not screw it up, and I'm sure some things will go wrong. Probably drivers will be off, not on, but it's just gonna be a matter of dealing with it. If that makes sense.
Is it the case where we just redefine, have the two symbols on for? I think you mentioned before. Like IRC or whatever, turn the two symbols on for one release and then drop the other one, so there's no release in which something like the Canaan, which is very specific, it gets broken.
I think then all we're gonna do is find nothing for a release, and then find everything we would have found. You know what I mean? But whatever. I don't really care that much.
Like I do have one, so I will. Anything I do, I will test it on the board. So at least it'll boot. Whether I miss something is a different thing, but I won't break its boot. That's for sure. It shouldn't be too hard to check the before and after of a generated config, I suppose.
For that special case, the intent was to use select for things that are mandatory to get a booting board. Otherwise, if you're like the peak or clocks, if that's or the CCTL driver, which is the weird thing, if that's missing, you won't get anything working. And anything else like SPI, I2C, you name it, it's just a default select that the user can actually deselect if it doesn't want it or doesn't use it. So the drivers for all the devices on the board are selected by default, but they can be deselected if you don't need them. Only the hardcore stuff to get something working cannot be unselected if you selected that SOC. That was the idea, which makes it simple for the user.
Yeah, I think it's like way too far down the rabbit hole to tell without just looking at all the selects and not screwing it up, if that makes sense. I can't keep all the K-config dependencies in my head.
Yeah, no, but that one was an easy one. I mean, it's not a lot of things on that board, so.
Yeah.
I guess the last thing on the slide then is the def config. There's still a bit of a mix of there's some stuff that's being turned on by default in the def config. I noticed that like we have the Radeon and NVIDIA drivers on, and then say for example when
people actually use this.
Pardon?
People use this.
Yeah, but like I do.
Yeah. Okay.
And so the other side of it is then say you have someone who has, I don't know, DRM SunXI for that only works on one specific SoC. Is that sort of thing, should that be done via defaults or should that be allowed in the def config?
And this is kind of how we got, I don't know, Higi, if you want to say something.
I think at least in my experience on ARM, the goal is to have the def config enable the kernel to boot on as much boards as possible, with most stuff as far as it goes as module, and only the most important things that you need to get rid of as built in. And then people can slim down the def config for their special case on their own.
Yeah, and that's how we kind of got in the situation, was just trying to track which, why each of those def config entries was in there by attaching them to an SoC config, if that kind of makes sense. But that's basically what we do now. And yeah, we'll just keep getting bigger. We probably do need to take some stuff and make them modules though, because almost nothing is a module in there. And stuff like an NVIDIA driver should be a module.
Drivers, the GPU drivers
they are okay.
Modules.
Okay, yeah, because they were so big for a while back when we didn't have module support, right? But my bet is that that whole list should probably be scrubbed, right, to just see what really doesn't make sense to have built in.
I think as part of this, there's probably some stuff in there that really maybe could be a module or could be a module that isn't, and whatever. There's probably a
I think it's one of those things where like nobody's really had time to just run through this, because without having a ton of SOCs floating around, the cruft doesn't really matter. Yeah, it's like for a while we just had sci-fi ones and the Canon ones, and they weren't going to run the same kernels anyway, so who cares? Right? But it's going to be a mess when we have a bunch. So yeah, seems reasonable. Hey, Atish.
So when you say core things like it also include the future specs like AIA or all those RVA standards, RVA specs that are drivers.
Sorry, I couldn't really hear you. Can you say that again, please?
Yeah. Oh, he just asked like, what about the next generation of RISC-V interrupt controllers? Do we turn those on all by default? It seems like
it should be.
Yeah. If you're building a RISC-V chip, you're probably going to use the RISC-V specs for those things. So,
Also, you most of the time will have the memory to keep this one driver around. And when you have really a special case board with a tiny amount of memory, then you need to trim the.
That's it. You're not going to run defconfig anyway, right? So
exactly.
It's not all things to all people. It's just some kind of reasonable thing. So yeah.
For me anyway, the value in defconfig is I can just slam in my CI, just run defconfig, and then I know something breaks or not. Like I don't really want to run it.
I guess if you know if the common stuff breaks, but I don't know. I still have an all mod config that's broken and every release, but whatever.
I only have 3 slides, so I think we're just done.
Yeah. Okay.
I brought the schedule back in line, maybe.
I don't know if anyone else has questions. The break is after this, so we can talk about stuff or go have coffee.
Who's next?
I didn't even look because I was just, it's the break, so I had
I'm
thought
not
that far ahead.
anyway, so I can't do it.
Robbie.
I was going to swipe up.
All right. Sounds good. Hopefully everybody can hear. All right. So good afternoon, everyone, and I guess morning, evening for anybody who's remote. So I'll be talking about confidential compute and present some of the discussions that are ongoing right now in RISC-V and what we sort of need to bring in this sort of functionality for RISC-V platforms. So I'll touch upon some of like the non-ISA discussions we're having in RISC-V terminology, also some of the ISA discussions we've started, and then also other platform recommendations and guidelines that would be required to implement such a capability. And yeah, just a quick acknowledgement to a bunch of other reverse colleagues and also folks in the RISC-V technical work groups that we work with that a lot of other folks are contributing to. So a quick background for folks who attended the confidential compute micro conference today morning. Probably this is a little bit repetitive, but I think it's good to quickly baseline, right? So we're aiming, this particular discussion is aimed at the security property of running workloads with high confidentiality, right, on a platform. And what that means is relying on some hardware-based capabilities so that the fact that you're running a workload as a confidential workload can actually be proven to a remote relying party, right? And the other aspect is you have to attest to a particular trusted computing base to that remote relying party, right? So we'll talk about some of the TE properties and how far we can go in terms of reducing that trusted computing base on the platform. Typically, what confidential computing tries to do is remove your host, other software entities on the platform. The starting assumption is, you're talking about a multi-security domain platform, so there is more than one entity operating on that system, right? There may be a host software entity that's managing VMs or processes or containers, and there's like tenants running on it, which are the actual VMs themselves, for example. So we try to make sure the VMs can run confidential or the containers can run confidential and keep the hosts outside the TCP. And that includes developers, operators, anybody who has an influence on that host software. So there's a pretty exhaustive threat model. I won't go through it here right now, but you can sort of take a quick glance at it. This is documented in some of the draft discussions that we started. A lot of the other architectures that have these sorts of capabilities address all or parts of this similar threat model, right? So some of the quick ones to point out is obviously when we're talking about keeping things outside your TCP, you want to make sure any accesses from that untrusted software or hardware is kept outside the TCP. And that means, keeping data confidential, ensuring the integrity of the code that's executing in your workload, right? Also preventing tamper from other elements, right? So there's confidentiality requirements, there's integrity requirements, and then there is some other sort of auxiliary requirements that come from the fact that your platform might be in different postures. It might be in debug mode, it may be in a production mode. So when it's in a debug mode of operation, you might want to make sure you are using a separate key hierarchy so that you're not divulging your customer secrets while the platform is allowed to be in debug mode, and so on. Some other critical threat model requirements are on attestation. Like I said, confidential computing is sort of for not if you're not doing any sort of attestation.
So can I just ask about your threat models? You don't mention encryption there. So is data encryption going to be an important part of your confidential computing base? I know for Trust Zone, it's basically an isolation model. And IBM 360 has the same thing. But ARM is thinking they're also going to move to an encrypted model because Intel does it and it's shiny as far as I can tell. Is RISC-V wanting to do the same thing?
So we want to call out some of the, in this threat model, we didn't want to say thou shall do this or that, right? We wanted to sort of call out here's the confidentiality and integrity requirements that we want to support, but how you actually implement it on your platform is really up to the threat model of that RISC-V platform that it's trying to meet. So you might have a threat model where you say, hey, I'm not trying to prevent against hardware attacks. So for me, an MMU-based access control model is sufficient for confidentiality, right? That is okay. Whereas somebody might say, no, I'm in an environment where it's an edge appliance-like device, and I want to prevent all kinds of hardware attacks on it, including some advanced side channel attacks, and then your requirements are that much more. So you'll sort of see that nuance in the architecture where we try to separate the architectural mechanisms and interfaces from the implementation, right? And how far they go to meet that threat model, right? Yeah, go ahead.
I was just told by Krista that they're working on getting WorldGuard actually open source. So that's an implementation of stuff, and it will have to be reconciled because this stuff wasn't done at the time they put that together. But that's sort of an example.
That's right. Yeah, thanks. So here's just a sort of a reference architecture presentation, or the model that we've been discussing in the RISC-V technical working group. So the working group is called the task group is called AppTE, or Application Processor Trusted Execution Environment. And this is a reference architecture that you'll see different deployment model mappings on in a second. But I wanted to sort of call out some key properties here that we are using as a starting point. So here our main goal is to meet sort of rich OS environments, right? So a couple of ISA aspects that we're relying on here is, first of all, we rely on the hypervisor extension. So that's a design choice that we made here as a starting point to basically say that we can support the notion of running a confidential VM. The advantage we have if we support the confidential VM model, that we can support sort of your user mode and your supervisor mode virtualized, right? And that gives sort of the most freedom in terms of software to run different kinds of workloads in this confidential environment. And then to be able to achieve that, there's a couple of layers here that you can see, and I'll talk about the hardware sort of guidelines at the bottom in a second. What these layers are essentially achieving is some key properties to essentially keep a large part of the host software out of the TCP, right? So as you can see here, as an example, we are showing a platform that is supporting virtualization itself. It's a host OS and an OS VMM environment. So think of this as Linux KVM as a prime example, and is running a bunch of non-confidential ordinary VMs, right? On the same platform, we also want to be able to host confidential VMs. So this model is showing a peer model of a new entity called a TE security monitor, right? Which is basically, in this example, RISC-V macro code running in hypervisor extension mode, or HS mode, of the platform or of the CPU. And it exposes two interfaces. One is called the TH ABI, right? That's the interface between the host OS software that's managing the workloads and then the TE security monitor itself. And then the second interface is the TG ABI, which is meant to be used by the confidential workloads themselves. The reason for this sort of partitioning is so that we can meet that design property that we want to uphold, which is keep all the resource management role still with the host OS or the VMM, which is really the operator on the platform, right? So we want to make sure that and you'll see this in our threat model as well, we want to make sure that just like regular multi-tenant platforms, a tenant should never be able to cause a denial of service on the host platform, right? And for that purposes, we want to make sure that the host OS or VMM is always in control of the resources on the platform and is able to make decisions about allocation and things like that. At the same time, we want to make sure that that host OS is not in control of the security properties we want to enforce. And that's why you see this TE security monitor here that's called out as a TCP element on the platform, right? And that's the one that says, hey, the host OS can still manage the resources, but when a particular resource is running as a confidential workload, that host OS or software does not have access to the secrets associated with that workload, right? And it cannot influence the workload in a way to cause its secrets to be leaked. Right? Now, to be able to achieve this sort of peer model separation that you see here, we have some TCP elements that we host in this picture in this M mode firmware, and that's basically called as the TSM driver, right? And so the TH ABI, which is shown as a logical interface here, and we'll talk about the interface in the plumbing details, is basically achieved through eCall intrinsic that is present in the RISC-V privileged ISA, right? So the eCall allows host OS to essentially invoke services from the TSM. The TSM driver ensures that context switch happens securely, right? So that the TSM itself is isolated on that platform, right? That's sort of the first part. And that's what this dashed line is trying to show, right? That there's a first level isolation for confidentiality integrity between the the TE and the non-TE memory. And then the non-TE and the TE memory is then partitioned by the TSM, essentially using the existing ratified privileged ISA H extension of RISC-V, because we can start using the standard first level and second level paging structure and MMU enforcement to essentially do that next level of partitioning. And there's a couple of deployment models that I mentioned are possible here, depending on how you want to run things on the platform. Right? And then last but not the least, there are a bunch of dependencies on the platform itself that are not mandated per this specification, because we want to really focus on the non-ISA interfaces. But there are some guidelines we want to put forward in terms of, hey, if since the TSM is in your TCB, right, we have some explicit guidelines on how you should use some sort of a hardware-based platform root of trust to extend that in the measurements of that TCB, right, so that you can support attestation models using frameworks like TCG DICE when you're actually validating whether you're running the right confidential workload based on the right TCB. Some of the other elements that are called out here, as James asked earlier, you may be using just like very basic MMU-like capabilities for isolation, or you might have memory controllers that go much further ahead in terms of encryption, integrity, replay protection capabilities. And that's really a platform ingredient property, right? And that's really where we sort of call out some guidelines that, hey, if you want to really protect against these kinds of threats, you might want to think about these kinds of capabilities, right? And then the IMMU is called out again from a completeness perspective, that for some of the basic, meeting some of the basic threat model, you might want to think about keeping devices outside the TCB. And then we can talk about what is the mechanisms to bring specific devices back into the TCB, right, as needed. So that's sort of a baseline. And here's sort of the couple of different deployment models that we can reason about with that base architecture, right? In both of these cases, the interfaces that we talked about, the THABI and the TGABI, would largely be the same, right? It's just like different manifestations of how the TSM could be implemented. Like for example, here the TSM is implemented to essentially completely occupy HS mode, or run as the only TCB element running in HS mode. So you can run the host OS essentially in VS mode, and you can simply start building something like this just based on the existing privileged hypervisor extension today, right? With these interfaces. Obviously, you still have to provide the measurement and the attestation capabilities even on this platform. Whereas this is sort of the model I described on the other foil, where if you want a system where the host OS still retains control of the physical platform directly, right, with interactions only with the M mode firmware, and you can support a peer-based model. In both cases, the THABI essentially is the one that allows these two entities to interact. In this model, obviously, you have some more requirements on the platform, and I'll describe that in a minute, right? Like, because you have to sort of partition this peer software running in HS mode, whereas in this case, you really only have your TCB elements in HS mode, right? So that's sort of the background. Let me pause here and take any questions before I go into sort of the discussion part on the different interface aspects.
Will there be any ISA changes in order to support this?
Yeah, so in this deployment model here, the one that we're seeing on the right, we have some ISA extensions that we're talking about, and really they boil down to we don't think we need any new instructions per se. What we really need is definition in the architecture for new physical memory attributes, right? So we want to introduce this notion of a confidential memory attribute, right? So RISC-V already has a definition of physical memory attributes where we want to add this new type, right, to explicitly call out that the notion of what does it mean for software to manage this attribute on memory. And as you'll see in the interface, we then have a model that the interface talks to of like, how do you convert memory on a platform, and ideally all of the memory available on the platform, from non-confidential to confidential, right? And the platform mechanisms in turn, like memory encryption and others, can back up that notion, right? So you might have some memory, for example, that is behind a memory controller that supports encryption, and that would be the sort of your regions of memory that could support that physical memory attribute, right? The TSM will enforce that TEs are always using memory assigned from those pools of memory. Right? So that's sort of the ISA extension mark to answer in a nutshell. Okay. So in terms of the plumbing, and I have a sort of like a life cycle chart later on that sort of describes the use of this this interface. So as I said, the THABI is an interface that we want to expose from the TSM to the host software, right? And these are sort of on the left-hand side, you see some of the intrinsics that we would need for host software to invoke into the TSM to be able to manage confidential VMs, right? So just quickly running through some of the key ones here. We expect some enumeration interfaces right at the top, which will allow the host software on the platform to first discover the fact that this platform supports this capability, and then come in and also get some information about what the actual capabilities are on the platform. Right. For example, you might have implementations that require a certain amount of memory to be carved out for a TVM before it is launched. Right. And this is for holding things like depending on the number of vCPUs associated with that VM, how much memory do you need for those vCPU structures or other paging structures associated with that VM. A couple of the other intrinsics talk about creating or destroying TVMs. So the idea behind this model is that the first set of intrinsics allow a host software to essentially convert some amount of memory into confidential memory, and the next set of interfaces allow that host to assign resources to a TVM for execution by allocating from that confidential memory, right? And the TSM, on the other hand, only enforces the intrinsics that confidential memory regions are carved out and allocated exclusively to specific TVMs, right? So that allows us to systematically build the context structures in confidential memory for those TVMs, right? And that's what some of the initial set of intrinsics achieve. And then one other one I wanted to point out, like these two interfaces here, adding measured pages or adding clear pages, right? This is to essentially support the notion of attestation. So as we are building the TVMs and the TVM is having memories being assigned, and the host is adding memory to that TVM, we want to support at least these two classes of memory, right? One where you're adding code or data, binary images that might be your initial kernel image, init.rd, etc., firmware image, that are part of the static measured image of that TVM, right? And that's what we want to support to support the basic attestation model, right? But to support different kinds of workload, we don't expect to measure the entire TVM on that first get-go, right? There might be only a bootstrap part of the TVM that you would measure as part of the static image, and then a larger part of the memory might be granted to the TVM once it starts executing, right? So that's why we have sort of these two classes of memory assignment, one which is explicitly measured, and the measurements of that are recorded by the TSM before the TVM starts executing, and others that are added lazily as the TVM starts executing. I won't touch upon some of these other ones because they are more sort of advanced, where we can discuss that more on the list. For as the TVM is executing, you probably want to support intrinsics like where you fragment the page mapping, or you condense the page mapping in order to use the TLB based on the implementation more efficiently. And then these are a couple of other intrinsics, like once you've instantiated a TVM that way, right? So you've granted it some memory, donated some memory to it from confidential memory regions, right? And you've completed the measurement process, right? There is sort of an intrinsic you invoke in the TSM to sort of finalize the measurements of that TVM, right? At that point, the TVM essentially becomes runnable, right? And these intrinsics that you see here are to basically execute a TVM vCPU context. So this would be when KVMs, and the kernel selects a particular context to execute, right? Those KVM, flows would essentially invoke these intrinsics into the TSM to be able to actually instantiate a vCPU context. And so this is where that partitioning that I was describing earlier comes in, where once you made the memory confidential, all host accesses to that confidential memory are prevented by the platform, and we'll see some of the intrinsics to be able to do that. And when you enter a vCPU, that's when the TSM actually performs the context switch of that, to load that virtual CPU state onto that physical CPU, right? And that virtual CPU state is stored in confidential memory, right? So that's how the TSM ensures that even though the scheduling decisions are made by the host OS or KVM, the actual isolation of the context is enforced by the TSM. And I'm not listing some of the other SBI interfaces here that we would need for other aspects like securing IRQs or binding IRQ files to specific CPUs, things like binding specific device functions to them, or other aspects that for which we will need potentially other SBI calls. So here's sort of yeah. Was there a question?
Yeah, you mentioned one of those has a mechanism for measuring memory when you add it. What is your definition of? What's your idea of measurement? What does the measurement go into? When can you change the measurement? How do you quote measurement?
Yeah, that's good question. So the idea behind measurement is what we want to capture there is basically think of it as like a cryptographic hash of the contents of memory, along with the mappings associated that are used for where that memory is placed with regards to that guest physical address, right? So those are a couple of the properties we want to capture as memory pages are added into the measurement of that TVM. And this is sort of the static part of the measurement. So we want a clean break between when these initial pages are added and before the TVM can start running, you can't extend. We don't want those measurements to be extended past that point, right? Now we can think of supporting additional intrinsics once the guest starts executing, sort of like the notion of like TPM has dynamic PCRs. You can think of that being supported in addition by the TSM, where you have a set of static measurements that are cryptographic hashes over these static content, and then additional measurements that are cryptographic hashes over things that are loaded by the TVM itself, right? So that, and then when we do aggregation, yeah.
That's actually why I ask. If you look at AMD's solution, pretty much just static. If you look at Intel TDX, it's static and dynamic.
Yeah.
So it's important to think through how these are going to go together and turn into a real usable attestation solution.
Yeah, if you can just hold your thought for a minute. I have a slide on attestation, so I'll cover that in a bit more detail. Okay. All right. So just talking about the sort of Linux KVM mapping for the flow that I described earlier, right? So hopefully this sort of shows like a build life cycle, right, for KVM. And what I've tried to do here is intersperse in the existing KVM flow where it would invoke these different TSM intrinsics, right? So starting from the top where the KVM gets the system capabilities to check, it'll invoke the get TSM info. When it's creating a VM through the KVM create VM operation, it'll set these TVM parameters, right? This is basically choosing, how many vCPUs, how much memory does it have, etc. As it's assigning memory to the TVM, it can assign shared memory directly, right? But as it's assigning confidential memory, those get measured by the TSM. One other important property I wanted to mention here is, as I was mentioning, that we want to also measure the GPA where the hashes of those contents are associated with for those pages, and the second level paging structure, which is normally under the control of the hypervisor, is essentially managed by the TSM in this model, right? So those second level paging structures are essentially allocated in confidential memory for the TSM, and this prevents certain classes of like memory remapping attacks, so that the host can't come in and arbitrarily change a GPA to HPA mapping when the TVM is executing. And then finally, before normally a VMM would just continue executing. Here it has to do this additional stage of finalizing the TVM so that its measurements are basically frozen, and then it can start executing or scheduling through the additional SBI mechanisms. Yeah, and this picture sort of shows the conceptual model of we want to reuse the H extension defined G stage page table, right, to essentially virtualize guest physical address space. And that's what is shown as the nested walk here, right? This is very akin to like other hardware virtualization architectures of whether you look at AMD's implementation or Intel's implementation. What is additionally shown here is this notion of the physical memory attributes being fetched, right, by the hardware. So again, how the actual memory physical address is converted to the physical memory attribute is implementation specific, but that the architectural property we want here is during these page walks, right, when the page walks are happening in the context of a TVM, right, we want the specific properties associated with when confidential memory is accessed, right? For example, the key fault conditions we want to enforce here is first, both of these paging structures would live in confidential memory, right? The first one by definition, because it's built by the TVM code, by the TVM kernel, and it would always use confidential memory to build those structures. And second is enforced by the TSM itself by design, right? So as memory is added to the TVM, the confidential memory is also used to create the second stage paging structures, right? And then the MMU or the CPU enforces the fact that while it's performing walks in the context of a CPU running in a TVM, which is recognized through think of it as like a microarchitectural mode of that CPU, it'll enforce that those walks are happening in confidential memory. And that is asserted by this memory tracking table lookup, right? So every time a physical address is accessed during a page walk, the CPU knows the context of access and it knows the type of memory that it's accessing, right? So it can generate these new fault conditions where if these walks happen in non-confidential space, or if it's non-confidential access coming into confidential memory, which would be like the host accessing a memory page, right? Or if it's a confidential CPU accessing, doing a code fetch, right? Or performing a page walk, and they happen to access non-confidential memory, right? Those are the two cases for which we want to generate new faults out of the MMU, right? And that covers both the cases, whether access is coming from the non-confidential side or the host, or is coming from the confidential side from a TVM. Right? And those are basically the new fault conditions. Yeah, so I think I talked about the non-zero or the cleared memory addition. Oh, this is a good sort of blurb to look at here, which has an implication on the interfaces. So anytime a new map, an existing mapping for a TVM is modified, we sort of have a new sequence defined here. Normally a VMM would just do the middle part, right? It would come in, it would modify it would ensure the vCPU is not running, it would modify the PTE mappings, and it would appropriately flush the TLBs if the implementation has TLBs. Here we want to make sure we are trying to keep the VMM outside the TCB. So we have to sort of guard band this functionality with a couple of additional intrinsics, right? One is to make sure, and recall that we said that the second level paging structures are under the control of the TSM, right? We want to make sure the VMM can't come in and arbitrarily tamper over the second level paging structures. So these guard band functions are used or provided by the TSM, so the host can come in and invoke its desire to specifically change certain mappings, right? And that causes the TSM to ensure that certain mappings are blocked, right? And that essentially means that new TLB mappings can't be created using those mappings. Then we let the VMM perform whatever operation it needs to within reason of that operation, and then ensure that the VMM comes in and flushes the CPU threads, right? And that's again validated by the TSM. So we make sure that the right set of actions have happened around a set of changes that the VMM is attempting to enforce, right, on memory. And if this protocol is followed, okay. If this protocol is followed, then we know that the invariants are in place for the mapping structures. So I just want to cover this one slide quickly on the attestation. There's a bunch of attestation interfaces we also started discussing in the trusted computing SIG that Samuel here has been discussing. And the question somebody was asking earlier, this is sort of the way we look at the attestation model, right? In a nutshell, since we are running out of time, we want to basically use the TCG dice model to essentially build up the layers as there was a talk today morning that Peter described, Peter Gonda from Google, to build up the layers all the way to a TVM, right? Starting from some immutable hardware root of trust, so that a verifier or relying party can essentially do a standard challenge response protocol, right? And think of basically as the CDI is generated across these dice layers, the TVM essentially ends up with a certificate chain that can prove its attestation, all that proves this chain of TCB, right? That's again a 10.
Yeah, we're done.
Okay.
Sorry.
No, that's fine. Yeah, I'll just leave it on this last call to action foil. So you can join the mailing list for the work group. There's a POC for the TSM that folks in Revos have been working on. That's online. You're welcome to go look at that. And then we'll continue some of the KVM interface discussions online. Yeah. Thank you.
No. Ugh.
Okay.
Dot at the top.
Yeah.
So I want to talk about my try to tune some in-kernel routines. Like, I'm a kernel developer at Will, and recently I did the extensions for SV, PBMT, and SIGBOM. So I already spent way too much time on code patching. And so what I want to try is to optimize functions like string compare, string len, and the mem functions. Because, of course, they are normally supplied by C libraries, but the kernel has its own implementations. And libstring-C in the kernel provides the very generic implementations that are completely unoptimized. And for RISC-V has slightly optimized generic functions for the mem functions, but you still reuses the generic string functions. And these generic string functions always take precedence when no other more optimized variant is available. So it's either the optimized or the architecture-specific variant or the generic one, which comes into play a bit later. And so the RISC-V problem is essentially that RISC-V is not a finite set of instructions, but we have extensions for old extensions, we have planned new extensions, and there may be even more future extensions, which can all influence the ability to do these functions more performant.
Yeah, like string and mem copy, different microarchitectures are probably even a bigger multiplier than different ISA extensions, right? So it's gonna be a lot. Yeah.
And you can mix and match all these functions on a core. Essentially, you can't really know what any core will support in the future. And yeah, exactly. And for example, work in progress stuff from I've seen in our repository is like these functions using the ZBB extension for a lot of stuff. And again, fast underline access. So essentially, for a string compare, I've seen implementations for ZBB plus fast underlined, which is faster than only ZBB, which is faster than the generic kernel function. And yeah, same for.
Yeah, I think you're going to see even more, right? Because Sci-Fi has byte forwarding, slowness, and so
it's just the ones I've seen so far. And for example, also the mem set can profit from ZB00. And yeah, there is a big bunch of stuff you can maybe optimize in the future. So we already talked about fast underline access, that it's not really, that you don't really know that is not part of the ISO string, and we need another way to detect if it's present. And yeah, I guess, do you put it into just the CPU node, or?
Right now, we do nothing. This afternoon, I wrote a patch to put in the CPU node. I haven't sent it yet. But yeah, hopefully we will.
Oh, cool.
Yeah, yeah.
So yeah, what I didn't really so far understand if is the stricter line, will this bite me, or?
Yeah, because, okay, so if you're going to do string routines, right, you got the code, you write the code, it's assembly, whatever, GCC is not going to mess with you. But all the other stuff that gets like your inline string routines, all that sort of stuff, with strict align, GCC is very heavyweight about like, I have to know it's aligned. Or I omit, byte instructions or whatever. And that causes lots of stuff that should be inlined to not get inlined, right? And the memcopy call is always expensive. And it causes stuff that is getting inlined to either be very big or very slow or whatever, right? I don't know what to do about that. I think this all extant architectures is not true anymore because of the, what's it called? The D1. One could argue that D1 being by far the most common chip should probably be what the default is. Right? So yeah, some sort of kconfig thing seems to make sense. My only worry is that we've had a lot of bugs with the M mode and misaligned access handler, particularly early on, not actually properly emulating misaligned accesses, and therefore it's not 100% a performance problem. Also, it breaks people. So it's kind of the worst option. So I don't know. Yeah.
Yeah. Also, like a kconfig option always you always have to decide one or the other. So there is no really unified.
Well, in this case, I don't think you can really do anything else, just because this is like for the long tail. For the string routines, you can do some sort of ifunc flavored patching thing, or you can patch different inline calls or whatever, right? But for just the sea of byte loads that you get out of mstrict align, I don't really know what you do.
Yeah.
Right. Anyway.
And yeah, there we have it. In glibc, there's this functionality that's called ifunc, where you have a resolver that runs at the application startup and essentially can select the most performant implementation you want to use in the application. And I guess we need something in the...
Yeah, something. I mean, ifunc is very user space, so we might be able to get away with something.
Yeah, it's just a similar, some sort of
similar
concept.
But the same sort of, give me the function pointer or whatever. Yeah.
We are working on unified discovery. Initially, it's just going to do existence, but then it will have parameters and unaligned access. If you read the spec, it has 3 options, right? And so once that's in place, then you can decide either on kernel boot up or launching whatever. You at least will have access to that information in a regular format. Today, it's up to everybody to decide for themselves how they learn about what's there. So
yeah, I mean, we can put it in the DT and find it pretty easily. That's a manageable thing to do. It's DT only, but whatever. I think the bigger issue is all the the kind of all the byte loads you get that are inline and whatnot. We're not going to JIT the entire kernel or something, so there's kind of no way. There's no way around this.
Yeah, and essentially to select between the different implementations, of course, one could think about static branches and static keys, but that's of course not really doable because for one, you create this whole bunch of things, and also static keys, the documentation already says that it's used for seldom used features, and so you penalize always one.
Yeah, I think for this time, for the string routines, because they're only function entries that we're replacing, we can do a more ifunc flavored thing. Ideally without the got indirect, right? But some sort of inline flavored thing.
That's my next one.
Cool. All right.
So the thing I thought about doing, that's the next question.
So I just I've got a slight concern here that you're selecting on the static information you've got, and yet how are you picking up the impact of microarchitecture? Because if you are, I mean, if you've got multiple execution, if you've got instruction fusion, it doesn't really matter what your instructions are. That's going to dominate on your performance. That's why you have microarchitecture models inside the compilers. So I'm wondering whether you're very sort of, you almost want a dynamic discovery of what actually is fast on your machine, because if you try and statically predict it, I think increasingly with architecture, it's not going to give you the right answer.
And there are other routines in the kernel, like the crypto stuff, that will try a bunch, see what's fast, right? It's an option. I hope it doesn't get that bad, but
yeah, I should just qualify this. I'm not an operating system guy, so if I'm talking hogwash, say.
I think, in my worry, the bigger issue though is, for the functions that we can replace, I think we can kind of deal with that. We'll have various flavors. We can select based on the ISA, right? We can try to look around in vendor-specific stuff, kind of an ad hoc thing. I'm more worried about what we're going to do with all the compiled code. What is the generic tuning, whatnot. But maybe that's more of a GCC problem.
So
anyway.
the idea I had was just using alternatives again. Because and then just once determine which one is to use, then just replace them and have like string compare itself being an inline function that then just calls the relevant one, and we replace the one with the
Yeah. Does this actually work though? Won't this not link right? Is that not true? This works when you link it with all the
I'm not
piece
just thought
relatives?
that the
Okay.
idea I had this idea on Monday.
Oh, okay. So you haven't actually written the code
While
yet.
preparing the slides.
You haven't actually written the code for this?
Not yet, no.
Okay, yeah, because I think this won't work because PC relative call relocations will be bad when these things move around. But anyway, we'll see what happens.
Okay. Yeah, it's more like I'm trying to see if I'm going in the right direction. And
I think this is the right direction. I think that exact code sequence won't work, if that makes sense.
Yeah, this was more like an idea, and and of course the thing that then may provide a problem, that there is no real sorting. Like you have one that's like string compare ZBB. There's also the one has its own bit minute routines.
Yeah, I think that's the term you're getting at with just, there's going to be a lot of these. Trying to look through what flavor of machine you're on and figure it out, it's going to be an unmanageable mess at some point. So, yeah.
I think it's worth saying is you are focusing on the right. We've done comparisons between trying to make RISC-V architectures go as fast as M1, and the mem copy and the string copy are absolutely central to that across all the software.
Yeah.
Because they come into everything. Every time you move a struct, fundamentally it's a mem copy underneath.
That's why there's so many comments, because it's like it needs to get fixed. It's real bad.
Doesn't this also do kernel wide though, and it doesn't address the differences that are per heart?
Yeah, so the misaligned access thing I added was a per heart DT string, but yeah, how do you handle per heart string routines? Like either you whack in a per CPU relative jump in there, which is going to be super expensive when you're calling it memcopy, right? Or you just kind of try to figure out which one's best across the board. Hopefully people don't build hardware that requires wildly different string routines between one core and the other. And if they do, it's probably not going to go so fast. So I don't know, man.
Yeah, I guess just determining the most common function should probably work.
Yeah, I think the hope is that with like focusing on the ISA extensions that are very relevant for these things, right? We can get most of the cases dealt with, and hopefully that's kind of good enough, and we get it done early enough that folks design their hardware to run their teams well and whatnot, and it doesn't turn into chaos. But we'll see. Yeah,
I'm not designing too crazy stuff.
Yeah, I think like basing an idea around hardware vendors not building something crazy is never never a way to live your life. Oh, online? Yeah, if you want to exit. Just escape. Yeah.
Yeah, I just missed the point about the per heart. So these will be selected per heart, like it will be detected per heart at runtime.
Well, but the CPU performance properties are per heart. Like if you have asymmetric multiprocessing machines,
Yep.
right, you might have very different performance properties between big and little.
Yes,
but
that's
then
what.
functions are not per heart unless your
Exactly.
static inline routine does a per CPU lookup, which is probably going to kill your performance on something like memcopy. So I don't know of a good way to fix that.
Okay, yeah, that's what I was
Aside
like.
from the hope that hardware vendors don't build things that need that, if that makes sense.
Yeah, with heterogeneous systems, it will go crazier. Another question was like, with the alternative like code patching, will it be? So the no, I have not asked the question. So the alternative gets selected based on currently it's all the vendor ID and basically vendor specific things, but then eventually it will be based on the ISA extensions or some ISA properties discovered from DT/ACPI.
Yeah, I think currently all our alternatives are basically for errata, so they look at the vendor string. This would require also looking at
Not
other stuff.
necessarily.
But
No, the SVB VMT and SIGFORM
right, yeah,
doesn't,
so there
doesn't
is a
look at the
string
vendor
now,
string, but
yes.
it's essentially the same mechanism, but lives in the CPU features C.
Yeah, yeah. So now we do have some that are ISA string based. So I
yeah.
forgot about that. So yeah, it's
So-
the same
so,
thing. Yeah.
It's
Yeah, we did
essentially
that for perf also. I forgot. Sorry.
Yeah. Yeah, and the misaligned access thing, I had added a CPU feature probe to do that. Just didn't do anything with it. So anyway.
okay. So where were I? Essentially, yeah, that's penalty free because you essentially replace one with the other, so it doesn't get slower for anybody. And yeah, what may be yeah, of course we need some sort of selection mechanism that I can't really fathom yet, where you have everything in some sort of list, and then because like with current alternatives, you can come into the issue that you have one alternative applying and the other also being valid, and then the behavior is not really defined.
Yeah, I think it's one of those things where like if we try to solve every possible problem, we're going to go crazy. So let's just kind of, for the machines that we have, right, and the routines we know we need to make go fast on those machines, let's sort that out. And then as more stuff shows up, we'll figure it out. You know?
Yeah, I'm thinking about, for example, ZBB and the D1 that essentially equivalent.
Yeah, which is yeah.
Yeah.
So.
Okay. Now, okay, that's not really valid because the D1, of course, doesn't have ZBB. So, Christoph had an.
What about making this available for vendor extensions? So when I'm a vendor, I have my own extension, which, for example, has load pair, which is simply optimized on my architecture. I want to use it in this use case, and I want to override whatever mechanism is provided in the kernel.
Yeah, I mean, at that point, there's really no difference, right? It's just another thing to select on, if that makes sense. It's one of the things that will make the list very big, right? Yeah. But yeah, it's really just going to depend on what those extensions look like, and whether or not it's worth selecting on the extension or just saying like, hey, we're on this mic architecture. There it is. Don't worry about the collection of extensions that are on it because we already wrote the code for this specific thing. So it's just, but that's one of those things where like if we try to solve every problem, we're just going to kind of go crazy with hypotheticals. So yeah. We have a small number of things. Let's fix those. Yeah, Mark's.
Mark has another question.
I've done appliances before in the past, and like this is just not an issue because you handwrite all the stuff, right? Because you're not going to go ahead and use off-the-shelf things if your particular application is performance sensitive. So presumably this is somebody's downloading a generic kernel and wanting to load it on an arbitrary system, right?
Yeah, so like as it stands, you can do build time configuration of most of these alternative based schemes and turn off the ones that you don't want. So if you're building a system that you don't have to turn on all the other stuff that may hurt you in some way. It's not perfect because no one's really building that stuff yet, but you know, it'll get there as folks find and fix the problems. But yeah, this is only for the def config that you might find in like a generic distro that just needs to run on everything, and then you have to live with it. So yeah, right.
So yeah, essentially. So the question I still need to solve is like the detecting underlined access, but that's a moot point now. And I had the unified discovery as one possible option. What I'm still not sure about, can I use the generic functions in some way? Like, get I shouted at if I modify libstring to somehow make them available to me.
Yeah, and that's what I was worried about last time I looked at this, and I thought, I'll just put it in Archer Scribe. But I don't know. There's only one way to find out.
But duplicating the very generic string compare.
I know. Yeah, it seems really silly, but yeah.
But then I think I get shouted at if I.
Yeah. So I don't know. You can try.
Yeah, and then of course the how to do the selection. So it's a lot of me not seeing the wood for the trees, and I just came up with the idea to use the alternatives again on Monday. So
I think that makes sense. Aside from that, I think the linker won't like it. So sorry.
Yeah. There's Mark again.
The other thing is, I mean, you've listed the issues with ISA extensions, but probably the dominant thing when you're talking about these memory operations is actually going to be the cache config, and that's going to be way different from implementation to implementation, right? You know, how much you unroll, how, you know, prefetch, blah, 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 all those things, right? So, yeah, I'm not sure that this is actually going to be dominant in the end.
How's that? But Mark, isn't that the same? That's the same issue I was making. It's the microarchitecture that is the fact you've got to take on increasingly these days. I think that cache size can be part of that.
Right, and my only point, Jeremy, at all was that there's microarchitecture issues with respect to which extensions you support and how you support them, and there's microarchitecture issues with things that you have to specify yourself, regardless, right?
Yeah, and particularly memcopy stuff, it's not like a lot of times you're not worried about the stuff that is in ISA, you're worried about everything else. And that's why we're worried about this gigantic explosion, like Jerry mentioned with the pipeline models, and it's kind of the same problem. I don't know how to fix that.
So I guess right now it's a lot of low-hanging fruit because like just using ZBB or anything will be faster than.
And I think that's the key here is like what we have now is very bad. So let's just fix the easy problems and see how it looks. Maybe it's okay, and maybe we don't have to have a million different microarchitecture specific string routines because people kind of coalesce around.
Yeah, I guess at some point the next variant also will have to somehow prove a bit that it's really faster.
That's it. That it's worth it. Yeah. Right. So yeah. But I think it will just be a pile of optimizations that keeps growing, and I don't think there's a way around that.
We'll see. Yeah.
So what exactly do you mean by selections with table for implementation sorted by performance? Do that offline and then update the table?
One of the ideas to somehow keep track of the available options, but I'm not yet sure. How do you keep all the options together? Because right now you have, for example, SVBBMT lives in CPU features, and the T-head erratas live in errata T-head. And how do you keep track of which are available?
Yeah, because we have here. Sorry, Tish, you go.
No, I was just saying which routine we choose, like just for the to start with, can we just rely on the kconfig and then we can play around with the kconfig based selections, and then once we have more sophisticated.
Yes, if we just do it in kconfig. I think some of this is going to need to be dynamic because we don't have the new instructions on the old implementations, right? So like CBOZ, you really want for memset sometimes. They kind of way.
I meant the detection happens dynamic, like from the DT string or whatever. But let's say we have two options, let's say A or B. Then which one do you choose? A or B option, which depending on A is faster or B is faster on whatever hardware, right? That's what you meant by table with implementation sorted by performance.
Yeah.
That's what I understood.
Like the glibc has this resolver, and like the example I had, it was like first this, then this, then this. But I guess that's my idea to somehow replicate.
Yeah, I think it makes sense. And the crypto folks have this, like Intel crypto stuff will benchmark at runtime still, right? Do you know? They do that?
They benchmark at runtime?
They used to. Okay, yeah.
That's a good point.
Yeah, so they just have the collection of things. They just try a bunch, pick the fastest one. And for things that are self-contained, like string routines, where you know they're not going to just touch memory all over the place, you can run them and you can benchmark them, you know. Yeah, there's a whole other can of worms. Yeah, but that's something we have to talk about as the performance numbers come through on the patches. Yeah, early on at some point. Yeah. Right, I mean,
that will
boot's
slow
kind
down
of,
booting.
yeah.
That will slow down booting.
Yeah, I don't think they do it like in line with the rest of boot. You know, it's part of the crypto, anyway, the initialization stuff. But that's pretty fine grained for trying to talk about it.
Okay. More questions, remarks?
So for the bit, the ZB, you can just use QEMU right now. Is that the only option, or I mean, because there's no hardware, right, with the bit manip, or?
From what I've seen, only in QEMU, but like as I said, the D1 has an equivalent.
Oh, it does. Okay, all
It
right.
also has some bit manipulation. So.
Oh, okay.
Sorry.
All the pulp chips have it as well, but they're different.
Yeah. They don't have it. Yeah, they're different.
ETH pulp, it has a predecessor of bitmanip, so you can see bitmanip happening there.
So another random implementation. That's good.
So when you said D1 has an equivalent, it's an errata also?
Vendor specific. First said vendor specific. Like they have an.
Oh, it's a vendor specific thing. Nothing related to the standard RISC V.
I mean, that's for them side, so. Not me. Saying it's errata, then it's an errata. So.
It's an X extension.
The what?
Custom extension.
Yeah.
No, that's not at all. The RISC-V is built on custom extensions. We encourage it.
That one is actually in the custom extension of Ghostspace. So it's a real custom extension.
Yeah, I mean, we are not going to finish that in 2 minutes. So.
Okay. That's all.
Do you want the microphone? It's there. Okay. Yeah, good.
Good job. Let me know what happens.
Should I get started?
Yes, please.
Yeah.
Okay. So, actually, I'm a little bit nervous, so please don't bite me. Okay. So my topic is RISC-V F-trace working with preemption. So, where do I go to the next page?
Should be right there. Actually, are you? No. Okay, so did they give you presentation rights?
Yeah.
Download manager.
Yeah,
How do you
if he's got
go-
presentation rights, he just needs to make the presentation full screen and press the right arrow.
Right.
No, I
so-
think Atish might have set it up for him.
Well, and where? But no, are you sure he's presenter? Because
Yeah, I think Atish added the slides. So
What?
just take presenter.
Oh yeah, so I have to.
Yeah, I already switched the slide, so take the presenter. Just
Yeah, it's just be a presenter now. You can do it. You see the slide that was on the bottom. You are presenter now.
Oh, okay.
So just
Say now, wait, and then with a full screen, we should still see.
Oh, great.
Right there. Now you have that slide.
Great. Okay, let's continue. And so the reason for this presentation is that in RISC-V, when we are trying to enable preemption and running F-trace, and we found some bug, and we found that this issue are very related to the ISA of RISC-V itself. And so I'm Andy from Taiwan and working in Sci-Fi. So here's my outline, and I will go into talk about RISC-V F-trace and RISC-V F-trace and the current implementation and its limitation, and propose our solution at the end. And so probably all of you have used F-trace, and F-trace is a framework aiming to trace Linux kernel at function call level, and we want it to be enabled and disabled dynamically, and without recompiling the kernel. And we want this to be introduce minimal overhead. And so to do this, most of the architectures use patchable function entry to reserve an NOP at the head of functions, and at runtime it patches the first instruction to a call instruction and do the F-trace stuff, and if the patch goes wrong, then it will result in some very strange debugging issues. And so here is how RISC-V implement F-trace and dynamically. So it also uses patchable function entry, and it reserved for 16 bytes for each function symbol. And then when we want to enable the F-trace, we patch those 4 not instruction to a sequence of instruction. It basically loads the return address and jumps to the F-trace entry, and then after F-trace is finished its processing, it jumps back and it restores the return address from stack. And we want this to happen atomically, because if we patch, if one core is running in a halfway patch sequence, and we will have a lot of issues there. And so in RISC-V, our current implementation is to utilize stop machine. So the stop machine, basically, it will just stop all other cores to a busy wait loop, and then use the core 0 to perform the patching. to patch all function entries.
I was gonna just walk over.
And
Weird.
and then so for so after the core 0 finish patching, and then it will resume other cores execution, and so that other cores will see this change like instantly before it is running in kernel, and it will and when it is start running code patching, all other code will goes into a busy wait loop, and then after the code patching has done, then all the other codes will restart execution, and it seems like the update has happened atomically to other codes. And so preference is that in stop machine, this is the implementation of stop machine. I have just copied some piece of code there, and then so we found that one function is very suspect, and we goes into that, and we found that actually this function is being marked as no trace. It means that this particular function entry will not be reserved for patchable function entry, and then we will not patch this function runtime. So that is cool, right? But we can look into this code. Here we have some RCU stuff related to preemption. So after we enable preemption, we found that we run into corrupted frame, and sometimes it happens. We trace back to the starting point of corruption. We found that it's executing some partially updated function entry of this function, and so we have seen, so if we execute it on a partially update instruction, things might happen, like we will be executing on an illegal instruction, or if the state frame is not, if some instruction is not being executed because it is being halfway patched, and then we will have corrupted frame because the return address is not correctly stored and restored. And in 5.15 kernel, we after enable preemption, we see this 1, 2, 3, 4, 5, 5, 6.
Okay, real quick, just one issue with the stop machine in preemption. Okay, so you're patching four commands that have to be atomic, correct? Yeah. So any function could be preempted in one of those four.
Yeah.
And right. Stop machine will continue and work and do all the work. You can wait forever for stop machine, and then when it's done, that task that was preempted will then execute half the instructions that it doesn't know about. Like, so it breaks the atomacy no matter what you do, and you could go through and put no trace. You might as well put the no trace on the entire kernel, yeah. Which kind of defeats the purpose of having ftrace. Yeah. So there is actually something, I was hoping Paul McKenney would be here, but there is a couple of things to make stop machine work. One thing is you actually have to modify stop machine. And I had a problem. I needed synchronization, and I worked with Paul McKenney. We have that RCU tasks that are RCU task or task RCU or whatever it's called now. It will the quintessential state is, or the quiescent state is at the schedule point, a voluntary schedule point, not a preempt schedule, a voluntary schedule. If you are able to have stop machine do that, so you run stop, like a special version of stop machine to say, hey, I'm going to stop when everyone has scheduled. So everything schedules once, or condition if it calls condition sched, or if it calls condition sched or schedule, and then you stop. So it won't just go through and kick off a core on every one. So if you can modify stop machine to say, okay, I want to make sure that everyone is at a preemption point, not a preemption point, a schedule point, not a voluntary scheduling point. So sort of like voluntary preemption. Whereas it will go through, and if something's in the middle of executing, Stop Machine will not preempt it. It will go until that guy gets to a point where it schedules. Then it will like set a flag in the scheduler, or something happens where it could be even a static, like a static branch. At that point, it's scheduled out. That way, you guarantee that when Stop Machine executes, nothing will be in the middle of it.
Yeah.
That's one solution. Have you looked at? I mean, what you did?
I'm just going to say, having taken a quick look at the slides, I think some of the later slides are about to answer some of that.
Or the other solution?
Yeah, there are some solutions on the slides, but if we let them carry on. And...
But I just wanted to say that if you wanted Stop Machine to work, that's one way to make it work. But yeah, we'll go on.
Okay. Thanks. And so we present a way that we don't want to use Stop Machine anymore. And so like what you have just said, even if we can patch this instruction atomically, like if we can use so if we use those so if we patch all those mentioned function as no trace, and we still runs into error because if a process being preempted in the middle of this function entry, and we turn off ftrace at that moment before the process is getting back, and then this particular function instruction will not be executed, and then we observe this kind of errors. Yeah, and so so before we trying to implement our own ftrace implementation, we looked into some other architecture, and so for x86 and ARM64 and MIPS and RPC, they don't use Stop Machine to perform code patching, and so we want to follow this architecture. So we are trying to do that way. So so first we look into ARM64. So it only patched one instruction at runtime. At boot time, at compile time, it compiled two knob into each function entries, and when at boot time it will patch the first instruction to move link register, and then if we want to after boot time, at runtime, we want to enable or disable the ftrace. We just need to patch one instruction here, and to patch it as NOP or patch as branch and link. And so for ARM, they have a term called concurrent modification and execution of instruction. It means that these kinds of instruction can be patched dynamically at runtime without explicit synchronization. And so patching NOP with BL is safe for ARM architecture. Sorry.
Isn't that what dtrace did?
Sorry?
Dtrace, the original.
No.
They used one instruction. They used one no op.
Yeah.
But they didn't detrace this. They didn't do the full function tracing, did they?
Yeah.
Well, it's proprietary. So there's proprietary code. So I never saw it.
No, but then Apple went ahead and did their own dtrace.
And proprietary code, and I never saw it.
Yeah, everybody. I mean, the actual code you actually see without a problem, right?
I
it's
never
your
saw
code
it because I didn't run Sun Microsystems, and I run Apple. So what's the question? Because right now they can't share it. It's probably its own license.
No. If you have your own code and you run it through the compiler, the code that the compiler generates is not proprietary.
Yeah, and how do they use it through the compiler? What exactly?
The compiler actually compiled in the no-op, right? And then they replaced it.
So ftrace came in 2008. So I don't remember them doing that.
So
then.
dtrace was 98.
Yes, but I don't remember them doing every single function tracing. But anyway, what's the point for this?
Well, I mean, you know, atomicity for a single instruction is exactly the solution, right?
Well, we don't know yet. Let him finish.
But I mean, there's prior art, is all I'm saying, and it seems like you should be able to do whatever was done in the past.
No one came to me with this before for the last 12 years. So you're the first person to mention this to me.
I'll introduce you to Brian Cantrell.
Okay.
He's the one who wrote dtrace.
Okay, so if I remember correctly, dtrace would patch instruction with break instruction, and so for x86. Okay.
No. Don't just continue.
Okay. Okay. So for we can not directly copy this idea because we have to use 2 instructions to perform a code that jumps beyond 4K. So we see another idea on x86, and so basically their things are a bit tricky on x86 because their instruction bytes are not fixed, and so for example, it uses 5 bytes instruction to perform a code in one of the code instruction. Yeah, they have another code instruction. So in kernel, it use a 5 byte code to call a function that is from a distance. And so these 3 lines are copied from the comments from x86 and ftrace. So basically, it will initialize per function entries as 5 NOP, and they are all 1 byte NOP. And then it at first when it is updating the ftrace, it will first patch the first NOP as INT3. It is a trap instruction, debugging trap instruction. So it will redirect the control flow of the function of the core executing on this function, and basically it can just redirect to the real function entry and in the trap handler, and then it tries to encode the destination address for the later code instruction, and then it update the INT3 to the OP code of code instruction, and after that it will be the other cores will execute on the correct function ftrace. It will enter the ftrace correctly, and it will not see any partially updated instruction. And so on RISC-V, how do we do that? Because for RISC-V, we have we must use AYPC and JAOR pair to perform a jump that is relatively far, and then as mentioned before, we might encounter this kind of issue where when the function the core is being preempted halfway in executing these 4 instructions. So here are some possible but not preferred the solution. So the first one is to try to disable and re-enable preemption at each function entry, and this is not very cool. So and the second one is to limit the jump to a 4K offset, and this is not very foreseeable as well. And the third one is so for RISC-V, the maximum immediate is that could be used from an instruction is 20 bits.
Well, actually, get this.
We could possibly encode the jump target with this 20 bits of offset, but 20 bit is not good enough comparing. Sorry.
Okay, can I
comparing to other architectures.
Can I ask a question about the architectures? Because the one architecture you've missed out there is peer RISC, which has exactly the same problem as you do, in that it's got a very limited relative jump range, and to get beyond that, you have to use 2 instructions. The way it works on peer RISC is that 2 instructions are executed atomically by accident of the way the delay slot speculation architecture works. And so we can always schedule 2 instructions to be atomic, and so we don't have the same preemption problem. Now, I think that's an accident of the way the pipelines are constructed, but could you do the same on RISC-V?
So actually, since that might be an architectural thing, and I don't know if RISC-V has that in the specification to be able to do that. So I will actually go back to my stop machine solution, because it actually works here too.
Yeah.
RCU SCED, I mean, it'll slow down, but what you do is you do a bulk thing. So this is the solution I would recommend if you really want to go without, you want preemption to work and don't want to use stop machine. You do this. You put the breakpoint at the very, very first instruction. Okay. So everything from now on that's entering is going to hit that breakpoint and jump over the whole set and go on, correct?
Yeah.
So you put the breakpoint on all functions that you want to enable. You call SCED RC or RCU tasks. Now you know that everything has not been preempted, because that's the thing that if you say or synchronize RCU tasks, when you do synchronize RCU tasks, that solves this problem. It guarantees you that no one at the return of that, no one has been preempted. Everyone's gone through a schedule. The quiescent state is a schedule, an actual schedule, which means that it wasn't preempted. So it might take a while. So you do the breakpoint, call synchronize RCU tasks, update everything else, because you know nothing's touching it, because everything's going to hit the breakpoint now. After you get out of synchronize RCU tasks, everything is hitting the breakpoint. So you do the update, call RCU synchronize task again. Now everything sees everything. You remove the breakpoint, and there you have it. You have the transfer fully complete, and nothing will break. It might. The only problem with this is that SCED or synchronized RCU tasks is a horribly slow operation, because it requires everything to get through a preemption point. And it's gotten better, but talk with Paul McKenney, we might be able to improve it a bit, but there's times where it could take 1 second or so to get through that. That's why you do everything in bulk. You do all the breakpoints. You might have to wait a second or two, do all your changes, wait a second or two, and then you finish it, and there you have it. Does that make sense?
Yeah, but I think that it's a little bit heavy.
Is it really bad if it takes 3 seconds to enable ftrace? Sometimes it does do that, because ftrace actually calls RCU stats because of the trampoline. We have dynamic trampolines in the thing. That's why we call it, because we can't, when you disable ftrace, we have to, and we will delete, or we're going to free the trampoline so we allocate a trampoline, attach it, and then when we disable it, we free it. So to free it, sometimes we don't let that function return until we go through the RCU tasks, because we have to make sure that there's nothing on the trampoline, and it has the same problem.
Wow. That's what I haven't think of. Yeah.
So that's something that you might want. I mean, like I said, I would try it and see what see if it's bearable. I'm not guaranteeing it will be. I'm just going to say that it is a solution.
So this also requires like the no op to breakpoint right that can be currently executing, right?
Yeah. So basically, it's exactly okay. The difference is this is
Like
how x86.
Yeah.
I wrote the code for what you just described is the code I wrote. So what we do in x86, because we have the same problem, we have to make sure that it's all CPU. It's all CPU. We have to make sure all CPUs see the state. So we put the breakpoint on everything we want. What?
Sorry, but that's Palmer's point. That putting that breakpoint on requires you can concurrently modify that instruction, which they can't do on RISC-V.
Wait. So no, you put the breakpoint at the top, right? So
but when you say put the breakpoint at the top,
at the very first one, the reg.
You mean not a compile time, right?
No, right.
You
This is
mean
at runtime.
when you want to ftrace it.
Yeah, when you want to enable it. Yes.
Before there was a no op.
Okay, so let's say there's 4 no ops.
Any number of no ops.
Yeah, 10 no ops.
Okay.
100 no ops.
Okay.
So you put the very first one, you put a breakpoint on.
Uh-huh.
And the breakpoint handler, when it hits that breakpoint.
No, but before we get there, the no op that you wrote to could have been executed at this, while right, while you were writing the breakpoint.
The instruction fetch is not necessarily an atomic.
Yeah.
Doesn't behave as.
Wait. You can't put breakpoints on?
So I think the key thing here is, I think what Palmer is saying is that it is not guaranteed in that case to execute as either a breakpoint or an op. It's what ARM would call
It can execute as any instruction.
So my question is, can you apply breakpoints to the kernel?
Not if you want them to work correctly. Now, no hardware actually behaves that way, so we kind of paper over it, and we can do that for ftrace as well.
Okay. I would actually work with the hardware vendors and enforce this. No, okay, so when I did this for Intel, it took us over 8 months to get, we implemented it and shipped it out so people were running this code, and it was 8 months after it was inside kernel, inside Linux and accepted and people executing it before Intel came back to us and said, yes, you can do that. So basically, I think this is a strong enough case to push the hardware vendors to do it. And now all the hardware vendors on x86 make sure that this works.
Yeah, and in practice, this happens, GDB and stuff.
Yes.
It's got to work.
Yes. So
But there's nothing saying it works.
No, so okay, yes, then you can't use breakpoints, period. You can't use this case at all. So I'm not a hardware person, so I'm only telling you if breakpoints works, this will work.
Yeah, and so I'm cool with that, right?
Right.
As long as that's kind of understood.
Right, and if it doesn't work, then you got to go back to stop machine. That's it.
Yeah.
Your only solution is stop machine.
Yeah, and there used to be some bits in some of the various specs about this, but not anymore. So now there is also the interesting wrinkle where so it doesn't work for breakpoints, but the no op to architected illegal instruction, which traps to the same place and therefore it doesn't really matter. For that one, even if you fetch each bit in arbitrary order, you still get either illegal instructions or not scary instructions. So it's exceedingly unlikely that anybody is going to manifest invalid.
So you could actually technically if you could put an invalid instruction in there, and it will only see legal or valid, right?
Yeah.
Then you make the invalid instruction into like a breakpoint handler.
That's it. They literally go to the same point already. There's no differentiation.
So everything is hitting this
the same,
is going to take an exception and go to the breakpoint handler. That breakpoint handler is going to move the IP address, then do. So you still are basically implementing breakpoints.
Yeah, no, that was my point. Is it happens to be the case for that one that the bit stuff works out, right? Which makes it really unlikely that any hardware is going to ever do something super weird there, right? Okay. But it's still not in a spec.
Neither is half the crap I do in Linux.
It's fine, right? It's just like that's why we ended up having a discussion about it.
Which I'm saying, did you have any more?
Yeah, I have one. Say more. And so before going into that page, I want to mention about ZICCIF in RISC-V. It means that whenever the RISC-V core support this, and a naturally aligned instruction could be updated atomically. Yeah. So we won't hit into a halfway patch instruction if the instruction is like if a 4-byte instruction is aligned at the 4-byte boundary, we could store to that address, and then either a new instruction is being executed or the old instruction is being executed.
That's something that you guys could do too.
And so going into our proposed solution, so we reserve more NOP at function entry, and we want it to be a kind of trampoline line approach. And so when in compile time, there are all NOPs, and when at boot time we since RISC-V has some we must be so the address of 8-byte double word should align at the 8-byte boundary, or it cannot be stored atomically. So we want to align the trampoline line into 8-byte align address. So we have two scenarios. So they are quite the same, but we can just look at the first one. So if the F trace is disabled, we place the jump instruction to jump to the real function entry and update the rest of the instruction to be either to load the trampoline line here and skip the trampoline line here. Yeah. So this when we want to enable the F trace, we just patch the first 4-byte align again 4-byte align instruction to AUIPC, which loads the upper bits into upper bits of program counter into a register, and then we try to load the trampoline line here with a load double, and then we jump to the F trace target. Yeah, and that is our approach, and it depends on being all functions being aligned to 4-byte boundary, and on GCC we have to use F align function along with F no guess branch probability to enforce all functions to be aligned at 4-byte boundary, because if we don't use if we don't disable the guess probability flag, some code function will not be aligned to the required boundary given by F align function, and that is the first one. The second one is we have to reserve more bytes to at each function entry, and it is a 500K increase of code size with 122K of functions. Yeah.
Yeah. So what's the? I have to make this quick because the conference is now over and I got to put things away. What is the? Or have you tested the overhead of these jumps?
I haven't tested.
Yeah. So you really want to see, okay, what's it like to have the jumps in there compared to not having it at all? So anyway, yeah, real quick.
Sorry, I was going to say, on ARM64, I've been messing around with some of this recently in F-align functions specifically. So I've hit the same issue there with GCC and cold functions and other things. Clang seems to do the right thing. But if we wanted to get that cleaned up in the kernel somehow, I would be very interested in doing that or working with you for that.
Yeah, if we want to.
Okay,
yeah.
so let's not go over time now because we get yelled at.
Yeah, I have to. I'm actually supposed to meet someone. I have to shut these things down.
Yeah.
I'm responsible for the conference. Thank you very much.
All right. Yeah.
Invite.
The umbrella. That's the speaker. So, no.
And our cups are stuck in customs.